Good evening, everyone.
Good evening, sir.
Good evening. Okay. So, Dhanya, shall we start?
Yeah, Ruby.
Okay.
Sure.
Okay. So today's plan is we want to revise from week 9 to 12, right? So let me start with the week 9 first. Is it visible?
Yes, sir, it's visible.
Okay. 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 So week 9 starts with something called as an optional type, which is basically extension of the stream, right? Which was actually there in week 8. So like in a stream we have find some kind of filters which will filter some elements out of the particular streams. If we apply a filter on a stream, and on the filtered result, whenever we are going to apply the functions like a max, mean, or find first kind of thing, now it will return the maximum element if there are some elements. It can return the minimum element if there are some elements. It can find first element if there are some elements. But what will happen after applying the filter? The stream doesn't return anything, right? So there is no element which is filtered out. So in that case, it's basically a empty stream we got. So on which if we put a max or mean, so there is nothing to return. So the situation where we don't have anything to return. So optional is a type which let us return a value when it is present. And if the value is not present, means I cannot return anything, it basically gives me something called as a empty, which is similar to null, but not exactly a null. So we can have, for a result of a max, we can have the maximum value. But if the particular stream doesn't have anything, I cannot find a max of the particular stream, I'll return a empty, right? Or a null kind of thing. So this is how the optional could be defined. So if my stream is a double type, it is optional of double. If the stream is of integer type, also optional of int. So like this I do. So this is a typical example where we generate the random numbers. So how many random number we generate? 100 random number. From there we extract the elements which are lesser than 0.001. So whenever few elements are generated out of this 100 which are lesser than this, so we can definitely find a max of it. But among these 100 elements, suppose there is no element which is lesser than this. So what will happen? This max will return something called as a empty, optional dot empty, right? So depends on the situation. I can have a value or I can have a empty. That's the thing. So optional is basically a wrapper which includes a particular value of a given type or a null or a empty, right? Okay, so what I will do if it returns a empty. So there are a number of methods which tell us like what I should do if I have an empty thing, right? So first there is something called as a or else, which gives us a default value, if the return stream is a empty. So here it is. So suppose this max rand, the maximum random number, it gets a maximum value. So that's fine. So it gets the maximum double value. But suppose this particular stream is a empty. So result of max is a empty. So then what will happen? If this is set to an empty, in that case, it will set the default value as a minus 1.0. So rather than setting it as a empty, it gives you a double value. So this is the default value whenever the max doesn't return anything. So that's the idea is. Similarly, instead of giving a default value, you want the result will be assigned with a value returned by a function. Result will be a value returned by a function. So previously you have seen or else do what? It let you assign a value to this fixed rent. But here instead of that, what I'm doing, we are using a or else get, which basically if this particular thing is empty, it basically call these functions and the return value of the function will be assigned to this fixed rent, right? Now, if this particular return value, this particular stream is empty stream, sorry, this is an optional type, not just stream type. If the optional is empty type, right? If I want to throw something, so you can use a or else throw, or else throw. So that means if the max rand is not a double in this particular case, rather it's a empty, it will throw an particular exception. So which exception you want to throw, you can explicitly mention that. So we are basically throwing a specific exception, which is known as a illegal state exception. Now, up to this, we have discussed what will happen if the return value is empty, means my optional type store are empty, right? So in that case, I can assign a default value if it is empty. I can assign a value returned by a function if it is empty, or if it is empty, I can throw an exception. So these are three functions for it. But if I want to do something, if the value present, then this is the function. So if value present, I want to do something. Like if I have a legal value for my optional type, right? Then I want to do some processing. So this is the way I can do it. And if it is not having a value associated with it, means the optional type is now right now empty. So the particular operation will be just ignored. The particular operation will be just ignored. Now this is much more extended one. It's a if present, if the value present for the optional, what I should do. If the value is not present for the optional, what I should do. So present or else. So it's say if it is present, then do this particular operation. If it is not present on the else part, just print no max. Just print no max. Now, as we have seen, the optional value you can get as a result of calling the functions like a mean, max, find first, etc. on a given stream or filter output of a stream, right? But what if I have to create a optional value, right? Suppose you are having a double value v, right? So you want to present it as an optional value. So how do I do it? So you can have an optional. So we want to say it's a double, right? Want to say it's a double. Then we'll say dot. Sorry, we don't have to write this here. Okay. We have to say off. Then we say v. So it's basically generate an optional type of it. So here will be optional of double. Say this is OP. OP will be assigned to the object of optional whose value is v. And if I don't want to give a value to my optional object, so I want to make it as an empty, that's basically optional of empty, optional dot empty. So value could be assigned using a off function, and empty basically represents a empty value, right? Okay. So if you want to transfer a null, so null and empty is basically different thing whenever you will actually use this. But whenever you want to transfer a null value into a empty, so you can use this. The map basically do what? We have learned a map for a stream, right? So remember, the map works for a stream in a way, the map works for a optional type in a different way, a bit different way. So in for a stream, what happens if I give a map? For each element, it applies a particular operation, right? For each element in the stream, it will apply a particular operation through a map, right? So that was the map whenever it is called with a stream type. But whenever map is called with the optional type, so here basically this is a optional type. So whenever the map is called with it, it will apply the function or the particular operation, right? If it is having a value, it is associated with a value, the operation will not be applied on the particular type if the content of this, or if it wraps a empty, right? It's basically associated with the empty value. It doesn't have anything, right? So what will happen? The map will return a empty, optional dot empty. Again, I repeat, if this variable is a optional type variable, or this object is a optional type object, if it is associated with a value, then map will be applied to that value and the result will be stored over here, right? But what if this is a empty. This optional type is a empty. In that case, map also returns an empty. So that's why you can understand whenever we use a map with an optional type, the result also optional type. Why? Because if value present, it will return a value. If value doesn't present, it represents a empty, it returns a empty. So the result over here, that can have a value which is result of this map operation, or it can be empty if the particular value is a empty. Okay, so next we want to look for this flat map. Now what if, see here I am having an optional type, right? So if I have an optional type, I can put a map. But suppose instead of optional type, just assume this is a stream of optional type. This is a stream. This is a stream of optional type. Right. So what I will do? So if it is a single optional type, if it is a single optional type object, on that object, whatever the value is associated with, I apply my function, done. But whenever it is a stream of optional type, for each of such object, I need to apply my map, right? For each of such object, I have to apply a map, and result also will be a stream of optional type. Because whenever I'll apply this particular operation, whatever written over here, for each of the element of optional type stream, each value is again optional type. So it may result a value which represents the output of this operation, or if the optional value is an empty, so it returns an empty. So I'll have again a stream of optional type as my result, right? So that is how I can use my flat map. Okay, so this is your optional type. I'll take your question at the end of this thing. Let me complete this first. Okay. If you have anything, please keep it noted. Okay. So now in week 8, we have seen this collection can be converted into streams, right? So how we can do that? Basically inside the collection, we are having a function called as a stream. So if I have a list, right? If I have a list, suppose it's a integer, right? I list, right? So if I want to convert this I list to a stream, right? How do I do it? I say I list dot stream. Another way of doing it, I can have a stream. Then I'm having a function called as a of, then I can pass my list object within it, right? So there are two ways we can convert. We can convert a collection type into a stream type. Now question is, whenever you are having a stream type, how do I convert it into a collection type? If you have a stream type, how do I convert it into a collection type, right? Okay, so what is the benefit of converting a stream type into a collection type? That's a question, right? Because for stream also I can do a traversal, right? So for stream, I can have a iterator, like I can have a iterator for any collection type, and I can iterate within a stream, or I can directly use this for each, right? I can use this for which function with a stream, which is a high level operation, a lambda kind of functions, sorry, which is a high level a function, not lambda, it's exactly, this is a high level functions inside which you can pass another function. So function having an argument, which is again a function. So this is a high level function like a for each. So it basically traverses every element of the given stream. Now, since I can also traverse into a particular stream, what is the need I need to convert a stream into a collection, right? Because collection gives you a much more flexibility. You are having different kind of collection. You can create a list, you can create a set, right? And further, you can go for also map, right? So there are different way and different kind of collections having different kind of facilities, right? So suppose I want it as a sorted order, I may go for a tree set, right? Suppose I want it as a sequence of my input, I can go for a list kind of thing, right? Or a linked list kind of. So depends on how, what kind of efficiency or what kind of order I need to traverse my element. So depends on that, I can decide which kind of collection I'll convert to which I'll convert my particular stream to, right? So let us first see how I can convert a stream to an array, right? So whenever you are having a stream, so this is my stream. So stream dot to array. Stream dot to array gives you an array, but it's an array of object class. It's an array of object class because it's a generic kind of array, you can say. So if the stream of integer type, so that will be also returned as an array of object. If you have a stream of double, that also comes as an object. So if you know what kind of stream it is, afterwards you can cast it, right? You can typecast the elements, right? Like if you want, this array has to be a the array elements are of type double, so you can pass every element and you can typecast it to a double. Or specifically, if you want to cast it to a specific type, so toString can have a argument like this. So if you want a string array out of it, you can do this. If you have an integer array, you can have an integer colon colon new, right? So you can do it like this. Okay. So how to convert it into a collection? So collection means we'll mainly focus on two things, like a list and a set. So you know, list and sets are basically two interfaces, right? From list we can get a array list or a linked list. From a set we get a tree set, then a hash set and linked hash set, right? So now if you want to get an instance of a list type or a set type, not specific list or not a specific kind of set, right? So how do I do it? So this collectors, this particular class is a utility class which is having a number of methods which are known as a factory method. Factory method normally means for the static methods. So how do you can understand this is a static method? Because I'm calling it as a class name dot of that function, right? If it is an instance method, if it is a member functions or a method, we have to create an object of collector, then that particular object dot the function name, we need to call it like this. But since this is a static function, we have to call using the class name dot the particular function. So these static methods of a utility class basically called as a factory methods. So these are all static functions. If you use a to list, you get a list, means your stream will be converted into a list. If you use a to set, it will be converted into a set. Simple way. But what if I want to get a array list out of it? What if I want to get a linked list out of it? So it's similar to this, right? So to list, if I don't pass any argument, it normally gives a list. But if I want a array list, so specifically I'll say it's a array list colon colon new. So you will get here the result as an array list instead, right? So similarly for set, if you want specifically to create a tree set, so you pass it as an argument, right? So your result will be a tree set. Okay. So now the collectors having a feature of summarizing a string, right? Why you need to summarize a string? So you know stream is having a sequence of elements, right? So if you want to get some statistics out of the stream, like you want to find out how many elements are there, what is the maximum element, what is the minimum element, what is the average value of the element kind of thing, any kind of statistics. So this collector class having a particular way to find it out, right? So if the elements of your collections of type integer, you can use this summarizing int. If your collections is having the, if your stream is having the particular elements which are of double type, you can have a summarizing double, right? If your type is a long kind of thing, you can have a summarizing long, right? So how to use it? So let us assume this is having all this is basically a stream of uh, strings, right? Stream of strings, right? So I want to apply, I want to get a summarizing on int. So I want them as an integer format. So I'm basically finding out the length of every string, right? So it creates a list, it creates a stream of the integers. So I convert into a summarizing kind of thing. So I call for a summarizing int, which results in an object of in summary statistics, right? So with this particular class, I can call these methods like a get sum, get average, get count. So what it give, like as I get, if as I apply it on a stream of length, so lengths are our integer value, right? So I can get how many such lengths are there, means how many strings we are having, what is the maximum length of the string, what is the minimum length of the string, what is the addition of all the length, what is the average length of the strings, right? So this kind of summary is possible. Now in the previous slide we have looked for how to convert a stream to a list and stream to a set. Now what about map? If I want to get a map out of it, the simple way to do it, this collectors having again a factory method to map. So to map, as you know, it will return some map, right? So suppose this people is a stream which is having the object of people class, which is having the object of people class, right? So now this people class having two things, it's having an ID and having some name, right? Now what I want to do in my map, I want to generate the list as an ID colon name. This is the mapping I want for each particular people object. So how do I do? I specify my key is a person colon colon get ID. Get ID is the accessor of the person class. Get ID is the accessor of the people class. Sorry, I got a mistake here. It's, let me correct it. Yeah, see, the class name is a person, the object name is a people. That's a mistake I have done here. It's a person, right? So it's basically a collection, it's basically a stream of person. A person having what? It's having ID and it's having name, right? And it's having the accessor functions like a get ID, which will return ID, and it's having a get name, which will return name, right? So for each object of person type in the people stream, it makes this as a key and it makes the name as a value. So I get a key value pair where ID is the key, name is the value. So we get the result as a map. So two interesting things we can use do with a map. That one is grouping by, another is partitioning by, right? Grouping by and partitioning by. Okay, so the work is almost similar. Say I want to group the people using the name of the person, right? Suppose I have I'm assuming there are many people, more than one people who are having the same name. Like Arup, there are 3 people, they're having the name as Arup. There are 2 people who are having the same name as a Bhaskar, but their ID is different. So what I want to do, I want to group them by the name. So I call for this group by, then I pass get name, right? So what will happen? What it actually will do? So it create a map. It create a map where for Arup, it basically store a list. What this list will have, suppose there is a Arup whose ID is 10 and name is Arup. There is another 20 whose name is Arup. Like this, we can have all the objects which is associated with the name Arup. I can have another which is a Bhaskar, so which is associated with another list. So that list will have suppose Leben Bhaskar, then maybe 15 again there is a Bhaskar. So it will have the list of the objects where the name is a Bhaskar, right? There is another method, that's a partitioning by. So partitioning by will basically segregate your stream into two collections. Sorry, not two collection. Actually, I mean to say into a map associated with two keys. Associated with two keys. One will be associated with when this condition given, the predicate given here, which is true. Another will be when the predicate is false. Again, I say in group by what will happen? In this particular case, depends on the name, it will group it into different list, and each list will be associated with a key. So the map is basically having a key value pair. So where the key is the name and the value is the list associated with the name. This is the simple thing. But in partitioning by, what we do, we pass a predicate. The predicate could be true or false depending on the particular object, right? So it creates a map where you have to keep all the lists which are associated with the true, means when the predicate is true, there will be another list which will be associated with when it is false. So now you can understand there will be always two keys. One will be the true key, another will be the false, right? So here I'll have a list associated with true for which the given condition is true. Here I'll have a list of person for which the particular predicate is false, right? So in this case, what I'm doing, I'm getting a substring. I'm extracting the name, the first character of the name for each name, and I'm finding out if it is the first character of the name is a, right? So for true, it will have a list of all the name which starts with A. And for the false, it will have list of all the person whose name starts with anything other than capital A. Whose name starts with anything other than capital A. Again, I tell you what is the predicate. Here the predicate say the first character of your string of the name basically has to be a capital A. So this predicate will have a value or return value as a true if the particular name is having a as a first character, capital A as a first character. So against true, you'll have all the names, the person object for which they're having a name whose first character is a capital A, and there will be a false which will having a list of person whose name starts with any other character than the capital A. Okay, so we move to the next. Yeah, Pritodip, you want to ask anything?
Could you kindly check the chat box? I had sent you a message a short while back.
Okay, okay. Is it okay now?
Yes, sir. It's much better.
Okay. Okay, so next we are having the input output stream. Although the name is same as a stream, but it's a logically it's a different thing. So whenever we talk about input output stream, we talk about some kind of device. It could be a file, it could be an internet, it could be a memory, right? From which I can read or I could write something. sorry, I told device, right? It's an input stream or output stream. So uh, I mean to say any object from which I can read a sequence of bytes or I can write a sequence of byte. So the source of my input can be a file, it could be a internet or could be a memory, right? And for writing a output, the output object could be again a file, it could be an internet connection or a memory, right? So internet connection means if you're reading something from your network or internet, it means you're receiving data from someone else. If you're saying you're generating an output or writing something on a network connection or a internet connection, that means you're sending data to someone else, right? So that's basically gives a some kind of understanding of what do we mean by input stream and what do we mean by a output stream. But specifically you want to look for something called a file input stream and file output stream, which are used for when the source of input is a file and the destination of output is my file. So want to do it for the input output stream, we want to do it only for the file here, right? Now, what are the classes we have? The main class here, input stream and output stream. Input stream basically represent or wrap any input stream object, right? So where I can perform a read operation, I can read 1 byte or I can read a number of bytes. Similarly, an output stream wrap basically any output stream object where I can write 1 byte or a number of byte at a time, right? Now this input stream further could be encapsulated within a file input stream. So I mean to say now specifically the stream I'm handling, the source of the stream is nothing but a file. So I want to read from a file. When I say it's a file output stream, so the stream I'm associated with, that's a file, means where I want to write a file output stream or a file, right? Now, using file input stream and file output stream, you can perform read and write operation, right? But the read and write operation has to be in terms of bytes. I can, using a file input stream, I can read a byte or number of byte from a file. Using a file output stream, I can write a byte or number of bytes in a file. But every time doing it, writing in terms of byte or reading in terms of byte is a difficult job as a programmer. Maybe I will try to write something as a primitive type, like I want to write something as an integer, I want to write something as a float or double or a string, right? Using some primitive type kind of thing. So that's why I can further encapsulate this file input stream by a scanner. So scanners class we have used a lot before for writing our programs, right? So if you attach the scanner with a file input stream, which in terms attached to any file. So this is attached to one file. Suppose this is a.txt, and this scanner is now attached to this file input. So that means whenever I request to read an integer, what will happen? The file input stream will read a byte. So it read a byte or set of bytes from the file. Then it will send the scanner, but scanner will assemble this byte in terms of integer, because this lets you read the data in terms of a primitive type. So using scanner, you have used all the commands like next, next int, next double, next line, right? So a next int means I'm going to read a integer. I'm trying to read an integer. I say next double, I'm trying to read a double. So I issue a next double. The request goes to the file input stream. File input stream will fetch the data in terms of byte. Further, it will be assembled into double. So scanner gives me a double value. So the entire thing happens automatically by the particular wrapper, which is scanner over here. Similarly, this file output stream can be attached to a file. But using this file output stream, I can write on the file, but that will be that file, that data has to be first converted into byte, then I can write it in the file, right? But instead of doing that, I already know this file print writer, right? So whenever we do a system dot out dot print ln, this out is a print writer object, right? So that's how whenever I use this print writer object, I can use this to function print and println, right? And using print and println function, I can write any primitive type, right? I can write an integer, float, double, a string, anything on a file. So that's again, if I want to write a integer, it says the integer, but this integer will be converted into a bytes. Then it will be actually written on the file. That is how it will happen. So then we are having for again primitive reading and writing, basically from the stream we are having the classes like a data input stream, data output stream. For primitive types, it's having a read int, read double, right? Read float, this kind of functions. For output stream, it's having a write int, write double, this kind of functions. So it can do a read write for the primitive types. There is a special class over here which calls a buffered input output stream, right? So how basically we read our data? So I say I want to read an integer, right? My file is there on the hard disk, but it doesn't read directly from the hard disk. It's fetched the data, stored somewhere in the RAM buffer. From there data will be fetched, right? Again, I say I want to read the next data. Again, my request will go to the buffer. It find out it's there on the buffer. No, again, it will read it from the disk, fetch it on the buffer. From buffer, it will be read. But buffered input stream having a much better facility. Instead of fetching the data one by one from the hard disk to the main memory buffer, it do fetch it block by block. So enter block will be fetched from the hard disk into my main memory, so that further reading is possible from the main memory itself. I don't want to request every time to the hard disk. So this is basically a much more efficient way to perform a read and write, because it lets you do a buffered reading writing. Means the data will be read as a block from the secondary memory devices. You got a pushback stream. So we have all used this read, right? But this facility was unread operation. So read to what? The input is basically stored on an input buffer. So if you say read, the data will be moved from buffer into your particular it will be fetched from the buffer. It will be removed from the buffer and it will be displayed to you, right? Means it is read. So once it is basically consumed by your read functions, it will be removed from your input buffer. But unread will do what? You can see the value, again put it back over the buffer. So do not delete the elements from the buffer. So that's basically an unread operation will do. It's called a pushback. You read it from the input buffer, then again put it back. Okay, so other than this, you are having a random access file, means you can read or write anywhere from the any position from the file, because whatever before whatever the stream you have read, those are basically do all sequential operation. You have to start your operation from the beginning of the file. So zip data, it will represent your input output, whatever the data you have in a zipped file. Okay, so from the week 9, the last topic is serialization. So in input output stream, what we have talked with about all are reading and writing in terms of bytes or in terms of primitive data type. I can use a next int to read an integer. I can use a read int from data input stream to read an integer, or I can use a write double from data output stream to write a double value. But can I read or write? Can I read or write an object directly from a file? I can do it, but I need to perform a read or write for every member of my object. So suppose there is an employee type which is having an ID which is of integer, and there is a name which is of string type. Then I have to write the ID separately, name separately, and which is not possible always, because in most of the classes the instance variables are encapsulated, so you may not be able to do it from outside. So that's why this serialization concept comes. So where you need to have a serialization, right? You can have the serialization in many a time. Whenever you want to save the object, you want to have a backup of the object in the disk, right? And you want to get back the object as it is after some time. So I'm doing a program, I'm running a program which is populated a number of employee object, maybe 1,000 of employee object is populated, but I need to stop my program. But all the objects are created on my volatile memory, that is on the RAM. So if I stop my program, everything will be removed from my RAM. So again, I need to repopulate my 1,000 of employee objects. So what I can do, I can save all those objects inside my hard disk, so that once I again start my program, instead of again populating my objects, I'll just fetch them from the memory. I'll get back my object as it is, right? So it's we do it unknowingly whenever we play a game, right? Because whenever we are playing a game, suppose some moment we want to save the game. So each object of the game will be saved something somewhere on my hard disk. So we stop the game some time later, maybe after few days, I want to again reload my game. I say reload. So what will happen? My objects will be again read from the hard disk and it will be recreated on my memory, that's on my RAM, so that I'll get the object exactly on the same state at the time I have saved them, right? So that's why the simulation again, the network communication also, it's efficient. Like suppose I want to talk to you, I want to send my object to you, right? So I'll do what, I'll write it into a file, I'll send the file to you, you raise it, get the object back. The simple way I can do this thing. So for serialization, your class must implement this serializable interface, right? Which is a marker interface, which marks that this class can be serialized. Means it can be written into a file, we can retrieve it into a file from the file. So what are the functions? If you want to save the object into a file, then you say write object. If you want to get back the object, you are having read object. If you want to save the object, you do write object, it will be stored on a file. If you want to get back the object, you say read object, right? Now there is a facility, if you want to avoid some particular instance variable to be written on the file, right? So you can mark it as a transient. It's again a marker kind of thing. So whenever it's writing the content object into the file, it avoids the transient member to be written on the file. So there may be a situation, each time object will be raised, some value has to be recalculated from the beginning. You don't want to save the last value or the current state. You want every time it will be recalculated, right? So in those cases, you may mark it as a transient, means it comes as an empty whenever you raise up the object. So that value will be recalculated once again. It may be a security issue. There is some data member which is storing some secure data. You don't want to save that inside a file, right? So you may mark it as a transient so that that particular portion won't be saved on the file, right? Or what you can do, instead of writing it in a default way, like how a serialization write it, you can write it in your way, right? So in that case, you need to say, I want to overwrite the write object function, write object method, and I want to implement in my way so that everything will be saved in a default way, but the transient thing I want to write it my way. So I'll define how it will be written on the file, right? How it will be stored on the file. So in that case, I may have to override the write object. And what are the members for which I will do the default action, like the default serialization is called the default write object, but which has to be written in a customized way. So those are the basically transient field. They have to be written in a explicit manner, right? So that's the week 9 is. So you want to ask anything, or you want to read something, or next you want to raise the question? Yeah, Ritodip, you want to ask?
No, sir.
Okay, okay. Okay, so you can ask afterwards also. I think next person can, yeah. Who want to start next?
Yeah.
Yeah,
Okay,
Nalini,
thanks,
please,
Arup
please.
sir.
Thank you,
Yeah.
Nalini.
Yeah, thanks, Arup sir. I will continue week 10. So, multiprocessing. What is meant by multiprocessing? Sir, am I audible? Yeah, can anyone tell? Am I audible?
Yeah,
Nalini.
you're audible.
Yeah.
Yes, ma'am.
Yeah, okay. Yeah, thank you. Yeah, thank you. So what is meant by multiprocessing? A single processor can execute multiple tasks in parallel. So what I mean by in parallel, so you can execute your program on any ID, right? So you are using Eclipse and you are typing some Java code and you are executing that, and parallelly you can listen a song using some, yeah, you using your browser or anything, and you can also you can do some browsing in the internet. Yeah, that all things you are doing in parallel, right? How this is possible? Even if your machine has single processor, these things are possible. So how this is possible? This is possible because your processor does time slicing. So what is meant by time slicing? So it will allocate what but some particular amount of time. So it will allocate, okay, from for first for this 5 seconds you execute this task, and for the next 5 seconds you execute the other task. So in that way your processor is able to do multiple things in parallel. And so how in this multiprocessing thing, each processor is an independent thing, no? So executing a program in your ID is not dependent on some, if you're browsing something on internet, both these two processors are independent. So there is like so whatever you do on browser, it won't affect the your web browser, no? Whatever you do on Eclipse, it won't affect your browser. You can do the things, right? So this is because each process is an independent thing in this multiprocessing thing. So how this is done is by using time slicing, I told, no, in the first so how the processor does this: in the first some microseconds you execute this, and in the next microsecond you execute this, and whatever the task so it is running some process. Let's take your Java code. In the okay, it has exhausted its time. Let's take 10 microseconds. After that, the processor should decide, right, which processor it should execute, which process it should execute. It depends on it prioritizes the what task, the process. So it will, so it is OS dependent. OS will assign some priority, and based on the priority it will execute the next process. And for in this multiprocessing, each process will have its own local variables. So whatever, so now you are executing your Java code, no, on your Eclipse. So it will have its own some variables, and while you are searching on the internet, it will have its own variables, some variables, okay. Those are like, so each process will have its own set of local variables. So while switching the task, while you are okay, while the OS is switching the task between one process to other process, it should save the state of all the local variables, and it also should load the state of new local variables. So it is like kind of somewhat complex, right? It should always, at every time while switching the process, while switching the task between the processes, it should what save the state of the current local variables, and it should also load the what state of the execute now next process, right? So it is somewhat uh, no, it is somewhat complex and it is somewhat time consuming, right? Also, yeah, but this is regarding the multiprocessing. Then what is then in the threads? So how it happens is like you can execute multiple process within a single application. That means using your browser, you can do some web searching, right? And also you can do some other task, you can download some other file or something you can do. That is, you are doing the same thing using the single browser. That is like so logically parallel action within a single application, that is possible by means of this threads. So here it will have what the each pro that whatever task, now your browser is doing different things, no? So here you will have shared variables. It is not like previously you have local variables, that are independent tasks, no? But here you will have shared variables. So now in this for this, your context switching will become easier. So if you want to switch from one task to other task, it will become easier, because you are not required to save the state of the previously. You are required to what save the state of the local variables, no? and you need to load the state of the new local variables, right? That is not required. But if you are using this threads, so but you will have some side effects also, that if you are
Nalini,
executing.
sorry, Nalini.
Yeah,
Can you
yeah,
zoom your
yes.
this a bit? Yeah. They
Yeah,
cannot
I was
see.
about to ask the same thing.
Yeah,
Or
thanks, sir.
or
Yeah,
you can go full screen on Edge. That will be better.
yeah, is it okay now?
Yeah, it's
Is
fine.
it okay?
It's fine, ma'am. It's fine.
Yeah, okay. So the thing is, like, yeah, in threads you will have what shared variables. Because of that, context switches become easier, but it will also have side effects. So yeah, I will discuss it later, what are the side effects. So how you can create a thread? Basically, you are not discussing anything about multiprocessing here in this. You will study about the threads only. So in the threads, how can you create a thread? By extending a thread. By extending a thread, you can create a thread, or by implementing runnable interface, you can create a thread. So okay, if you are extending a thread, then you need to define the run method. In that run method, you need to place the task which you want to execute in parallel. Similarly, if you implement runnable interface also, you need to define the run method, and you need to put whatever the tasks that needed to be executed in the that you want to run in parallel, you need to put them in the run method. So after creating the thread and after writing your run method, you need to you need to create the object of that class, and also you need to you need to call run start method, not the run method. So what run method does is, like, it will simply execute whatever it is present in the run method in line by line, and it won't initiate the new thread. So if you want to initiate the new thread, that means if you want that task to be run in parallel, you need to start that thread, so that the thread can be started by calling the start method. So you will define the object of the class that extends the thread, and you will call start method to create separate thread. And similarly, while you if you okay, so always create, so you want a class that should be that should run in parallel, that should, like, you want to execute the tasks in parallel. But okay, if you are extending a thread, but your class cannot extend the other classes, no, the multiple inheritance is not possible, right? So that is not always comfortable, right? If your class is extending thread but you want to extend other class also, that is not comfortable, no. So instead of that, you can use runnable, you can implement runnable, and you can make your thread to run in parallel. And so if you implement the runnable interface, you need to define your own run method, and also you need to define the what you will implement the runnable, your class will implement the runnable interface, you will define your own run method, and you will similarly you will create the object of that class, and you will create a new thread, and you will pass that object to the thread, and you will you will start the thread. I think it will be clear if you see the slides. Do I need to show the slide, or is it okay? Everyone has idea, no, how to do this?
It will be better if you can show the slides.
Yeah, okay, just a minute. Yeah, okay. Yeah, just a minute. I'm just loading that. Okay, but in the sir slides, I think sir hasn't done that. I should open one of the what assignments only. Okay, I will show it, but it will what? I will explain the other things also in parallel. Yeah. Okay, this is like creating the threads. Next thing is like race condition. So previously we
Nalini, you
discussed,
have
right?
to share your slides. I think it's not visible.
Yeah, yes, sir. I'm sharing. Sorry, I forgot. Yeah. So it is clear, right? How to create the thread and what implement that. I will show that in assignments. Okay, how to do that. One of the assignment question I will pick and I will show after this. So next thing is trace condition. Previously we discussed, right? In threads they will share the variables. So I told, right, it will create the problems. It will have side effect also, because okay, if you are doing something on a thread and okay, you have some variable called some status variable. Let's take boolean status. It will be set to either true or false. So if the status is true, it should perform some task. If it is false, it should not perform the task. So now the two threads are operating on the same as the threads share the variables. So if the two threads are running the parallel, so one thread is trying to, if the one thread makes it as true, but the other in the other thread also, so it is in what other thread is checking for that what condition. If it is that thread is checking for the status variable. So if it is true, it will like perform the some task. In this thread, it is like if it is updating the variable to false, it won't perform the task, right? So yeah, it will have some side effect, no? So your thread wants to do something, but your other thread is doing some operation on that thread and operation on that variable, and the variable it will lead, and that what it will lead to the data inconsistency, right? So this is called what race condition. Concurrent update of shared variables can lead to data inconsistency. I will show this also in one of the what sir has used a very good example. Like yeah, I will show that example now. So yeah, so you have a bank, so you have a class called bank. In your bank, you okay, there is one limit, so you can create only 100 accounts. If assume like you can create only 100 accounts, so whatever operations you can perform is like you can whatever operations you can perform on that bank accounts, only you can transfer money, or you can you can transfer money within the bank accounts. I'm talking, you can transfer money to some account, or your account can get money from some other account, right? So assume like a bank has only 100 accounts, so you are performing the what transfer operation, and while performing the transfer operation, you are simultaneously checking what like the amount which is present in all the 100 bank accounts. So it should remain constant, right? So whatever transactions I told, like it is possible only within the 100 accounts. Let's assume like whatever transactions you do, it is possible only within 100 accounts. That means you can either you can transfer, let's take 100 rupees, you can transfer 100 rupees to some other bank account, or you can get 100 rupees from some other bank account. So the amount across all the bank accounts should be constant, right? So if all the 100 accounts, let's take it, if the sum is like uh, 10,000 or something, it should be constant, no? Whatever operations you do within the 100 bank accounts, it should be always constant. Because if the account is getting if the money is getting transferred to one account, it will be debited from other account, so the sum remains always constant. So but if you use threads and if you do that operation, that means you are performing transfer operation, and also you are performing audit operation. You are performing transfer operation using one thread, and audit operation, let's take you are performing audit operation using other thread. Then what will happen? So these two tasks are executing in parallel. So okay, you are trying to what uh, transfer 100 rupees from your account to other account. That means 100 rupees will be deducted from your account. So your account balance will be now 900. Your account balance will be some amount, but 100 will be deducted from your balance. But if you perform the audit operation at the same time, so your balance won't be 10,000, it will be 100, 10,000 minus 100. So it will be 100 less than the whatever it should be, because you have checked the audit before updating, before, like the whatever the amount 100 rupees I told, no, 100 rupees has not credited to other account, but you have tried to but you have checked that audit thing. You have checked the balance across all the accounts. That means that what your balance won't be, the balance in the other account has not been credited, but you have checked the audit thing. So you will get 100 lesser than the whatever it should be, right? Why is this? Because you are not performing transfer separately and audit separately. If you perform transfer separately, then your account will be debited from by 100, and other account will be whatever the account which you have credited will be credited by 100. Then your audit will give proper thing if you do them separately. But as you are using the threads and these things are happening in parallel, that means before what crediting to other account, you are checking the total balance across all the accounts. That means you are what you are getting some inconsistency in data, right? Because you are doing the things in parallel. So what is meant by race condition? Concurrent update of the shared variables results in unpredictable outcome. It will leads to the data inconsistency. Yeah, is it clear what is meant by race condition?
Yes, ma'am.
Okay, so yeah, I will show the other thing. So what is my screen is visible, right? So what is critical session? The sessions of the code where the shared variables are updated. So what critical sessions means? The sessions of the code where the shared variables are updated. That means you are previously updating your what accounts, and simultaneously you are checking account balance. So here whatever things, whatever the like what are the shared variables here? Account only, no? You are checking you are transferring the amount between the accounts, and also you are checking what balance in the of the accounts in the audit function. So whatever the code where we are acting on the shared variables, that is called the what critical session. And mutual execution is like at least only one thread, at most one thread should act at a time. It should act on that only the critical. So at most only one thread should act in the critical session of your code. That means, yeah, I think Danya ma'am will discuss more on this mutual exclusion thing. Yeah, it will be in that what continuation thing. So this can be done by by synchronizing thing. Yeah, so now we have discussed the transfer and audit methods, right? So transfer is like it is operating on the balance of the account, and also similarly audit also you are checking for the accounts. So whatever, so at most if you make only transfer to what execute at a time, while executing the transfer, if you are not making the audit to execute, then that is called mutual exclusion. That means you are only at most one thread at a time will act on the critical session of your code. Okay, yeah. Is there any doubts still here? Yeah, I will show that runnable thing. You can ask. Meanwhile, you can ask your doubts. If anyone has something. I hope no, right?
No, ma'am.
Okay. Just a minute. I will show that runnable thing because someone has asked, no, how to do runnable. How to create the thread now.
So Nalini, shall we continue this, and then once you are ready, shall I come back to you?
Yeah, yes, ma'am. Yeah, definitely. Yeah.
Sure. Okay, so from, I think I'll just continue with that mutual exclusion part that Nalini is talking about. So let me just share the screen first. Is this visible?
Yeah, yeah.
Yes, ma'am, it's visible.
Yeah, thanks. Okay. Yeah, so the one thing that Nalini stopped at saying was that at most one thread at a time can be in the critical section, right? So this is to ensure that the update of data for shared resources or shared variables happen in a way that does not lead to any data inconsistency. So we had also discussed earlier about this ticket booking. So even if it's a train ticket booking or cinema movie ticket booking and everything, where you have to either you get requests from multiple sites from multiple users which are actually initiated in multiple threads, and then there has to be a synchronization. There has to be some form of an understanding between various threads such that all of them do not enter the critical section and end up in data inconsistencies. So that is the whole idea about mutual exclusion, that is mutually excluding each other when it comes to entering the critical section. Okay, so that's about the mutual exclusion. So we discussed some approaches. I've actually discussed some approaches in the lectures on how to achieve this mutual exclusion when two threads are trying to access the same segment of code. So the first approach was using a two-valued variable where those two values were like 1 and 2, which denote the, so this is the code which you saw the other day. So this has a variable named turn, which takes two values, 1 and 2. One standing for the fact that it is the turn of thread 1, and turn equal to 2 means that it is a turn of thread 2. So when you are actually waiting for that, I mean, when the thread 1 sees that it is not the turn, it is not its own turn, then it enters what is known as a busy wait. And thread 2 at that point, so because the turn is a single variable, it can either take only value 1 or 2. So if it is not 1, then clearly the value is 2. And hence the while loop for thread 2 will see that it is equal to 2 and it will enter the critical section and set it to say, okay, it is your turn now. It is saying to thread 1, okay, it's your turn and you can carry on. And that's how the synchronization between these two threads happen. So what could be the problem that arises in a scenario like this is when at some point one of these threads encounter some kind of an exception or some kind of it has some it exits for because some certain condition is satisfied or something like this happens, and the other thread is actually waiting for a signal from the second thread, whichever has lost interest. And even though there is no execution, there is nothing that is happening at the processor side, it will still end up in one thread being deprived of the opportunity to enter the critical section. So this is what we refer to as the starvation. So in the case of starvation, one thread is being starved of the resources by the CPU or the memory resources, because the other thread for some reason is unable to proceed and reach the step where it has to hand over its turn to the other thread. So that is this approach. So the problem with this approach is clearly that it could lead to what is known as a starvation. The second procedure that we saw was using a single Boolean variable. So here, as I said, there is a variable which can take 1 and 2. So, what is the difference between this Boolean variable and this variable? Clearly, two Boolean variables, not a single Boolean variable. It takes two Boolean variables. I'm sorry about that. So two Boolean variables, each of which can take true or false value, indicating whether it is its own turn or rather it is interested in entering the critical section or not. So this is the code for that. So request 1 equal to true means that the thread 1 is expressing the interest to enter the critical section. So when it reaches, when it reaches this step, thread 1 is saying that, okay, I'm interested in entering the critical section. And then it checks whether, okay, when request 2 is true, it means, okay, thread 2 is also interested. So let me just enter this wait state. And then once the request 2 becomes false, which is happening at this position when thread 2 has completed execution of the critical section of code, and then it checks for this while condition becomes false, and it leaves the busy wait condition and enters the critical section. So here we are going to use two Boolean variables, one for thread 1, the other for thread 2. Now, what is the problem with this? Does this have the starvation problem? It does not have the starvation problem because it is not, even if something happens, like some exception happens here, right? It does not matter because, I mean, at least until this step, okay, if some starvation happens until at this step, the request 2 is not still set to true, and therefore this condition is not satisfied and thread 1 can enter the critical section. The same thing happens for thread 2. If suppose thread 1 loses interest and then it checks for the request 1 value, which is false, and it can enter the critical section. The problem is when both of them reach this step at the same time, what happens? Both these values are set to true and both of them will check the while loop at the same time, in the sense that, okay, when I say same time, it is not the exact same time, instance of time. Say you have something like t, here it is t, here it is t plus 1. Both of them are checking at the same time, right? So this is like before anything can happen to the request 1 or request 2 variable, leading to a conclusive control for each of the thread, it reaches this while statement, and at this point what happens is both of them see that both are true, and they don't realize that, okay, the other one is also waiting for me. It is assuming that the other thread has entered the critical section and it enters this busy wait. Both of them enter the busy wait, leading to what is known as the deadlock situation. So how do you avoid this? There is something called as a Peterson algorithm. So this is wrong. So this is again two Boolean variables. Okay. Okay, I have not copied the Peterson algorithm. I'll just share that. Just one second. Is this visible?
Yes, ma'am.
Yes, ma'am.
Okay. Yeah. So here there is this. What the Peterson algorithm does is it makes use of both the Boolean variables together. Both the Boolean variables, right? The request 1 and request 2, as well as the turn variable, which is a two-valued variable. So it uses a clever combination of these two variables. So it places the variables also appropriately around the while block and the critical section, such that the scenario of starvation as well as deadlock is avoided. So I've explained this in the earlier session. So if somebody wants me to explain it, I'll explain it again. Or for the sake of time, I can proceed. Does anybody want me to explain how this is avoided?
No, ma'am.
You're okay, right?
Yes, ma'am.
Yeah, okay, sure. So you can again go back and see this lecture. So, okay. So it's clearly, okay, let me just go back to this. Okay. So this way you are actually you are able to avoid the starvation problem as well as the deadlock problem by a clever use of both these, the three variables. Okay. Okay. Now the problem is, how do you generalize it to more than two threads? For that, we use what is known as a bakery algorithm. In this algorithm, whatever threads are there, they themselves, what they do is they try to acquire a token number, which is equal to the max plus the current max plus 1. They assign themselves a token number, which is current max plus 1. Now, what happens if two threads get the same number? Then there is some resolution which happens some tie break which is happens using some system parameter like the thread ID or the process ID or whatever. There is also the other way to do it, where if we ensure that this, so this is some kind of a test and set, what is known as a test and set operation. What is a test and set? You are actually checking for the value of the current max, and then you are setting it to some value, right? So if these two can be together done as an atomic operation, as a single operation, then we can avoid the situation where we need to do a tie break. Okay. So what is this test and set operation? That is what is there in the next lecture. Okay. So okay, what is test? Test is you check for the value of some variable. Setting is setting the value of that variable. First test and then set. Okay. So most of the time when you do a test and set, you are assuming that okay, I am testing for this condition and then I am updating it and ensuring that there is some mutual exclusion that happens as a result of this. Say for instance, two threads, right? In the case of Peterson algorithm, we've seen that while loop. While loop, I mean, it is not really a test and set, but what it does is again checking for the value of a Boolean variable, even though it's not setting anything. It's checking for the value of a Boolean variable and proceeding to do something. But as you can see, there is a time instant at which both of them can be checking it in the consecutive steps, which can again result in a situation where there is no mutual exclusion, and it can actually lead, okay, of course, it doesn't lead to a not problem. I mean, it doesn't lead to a race condition as such, but it leads to what is known as a deadlock, right? So if you really want to implement, so more than one thread does this updating parallel, updates may overlap and get lost. And if you need to combine test and set into an atomic and indivisible step, this cannot be guaranteed. If you write a program and say that, okay, if I'm testing for this variable and doing it only if this is not set a particular value, if I'm going to do it programmatically, it is never a guarantee that it will ensure mutual exclusion. So this is something very important, something very crucial. If you're looking for a value, if you're trying to synchronize based on a common variable, say you are checking for this value and then doing something, assuming that the other thread will not be, I mean, the very fact that you are checking for something and setting it does not ensure a mutual exclusion, because the other thread might also be doing the same thing in consecutive steps, and this might actually lead to a race condition. So how do you do this? This has to be implemented, or this construct, or this functionality of the test and set being atomic, right? So what do you mean by atomic? Atomic means that the test and set happens together. Either it happens or it doesn't happen. If it happens together, or it doesn't happen at all. So for both, if you are giving the test and set operation for two threads, for the thread it happens together. So there is nothing that happens between test and set. So if condition is being checked and then the variable is being set, there is nothing that happens between these two. So as I said, like t and t plus 1, right? So t plus 1 has to be the set operation. So this is the atomicity. By this you are actually ensuring that these two values, I mean this particular value which is coordinating the synchronization between the two, does not get updated at the same point. That is the atomicity, and this cannot be ensured by our programs. This has to be given to us by some programming language primitive. In general, it is done using what is known as semaphores. And so how does the programming language does it? So programming language, the Java virtual machine somehow communicates with the operating system, right? So whenever we generate the bytecode and it is run in the it is executed in a local machine, right? How does it do? There is a communication that happens between the Java virtual machine and the operating system internally, right? Okay, so people are not from the computer science background, you must understand that the Java compiler code gets converted into the bytecode. Sorry, the Java source code gets converted to the Java bytecode by the compiler. This Java bytecode is what gets executed at the local machine, wherever you are running the Java program, and that the Java virtual machine has a communication with the local operating system by which the bytecode is translated to what is known as the machine code, which suits the architecture of the local machine on which it is running. So this communication, the communication that happens between the Java virtual machine and the operating system, ensures a test and set operation. Sometimes this test and set is implemented as a hardware operation. Sometimes it is also implemented as something called as microprogrammed operations. So these kind of operations are implemented at an operating system level, and the communication between the JVM and the operating system enables to do that. So programmatically, what do you get is, how do you do this? How do you communicate to the JVM that, okay, I want to do this as a test and set, as an atomic operation? You do it using semaphores, you do it using the logs, all those things. Bhaskar will be explaining it in the towards the end of the session. So yeah, so that's about the semaphores. So what do semaphores guarantee? Guarantees mutual exclusion, freedom from starvation, and freedom from deadlock. Okay. Yeah. So I'll wind up here, and Nalini, if you are ready, you can continue.
Yeah, yes, ma'am. Yeah, yes, yeah. I'm sharing. Just it will take less than 1 minute. Yeah. So just I'm an example like how to create the threads by using this runnable interface. So you can see here class point that is implementing the runnable interface. So if you are implementing the runnable interface, then you should define your own run method. So we are defining run method. So point class is defining the run method.
Excuse me, ma'am.
Now you are create. Yeah, yes.
Ma'am, can you please zoom in the image? Code is not fully
Sorry.
visible.
Yeah, this is not. Yeah, okay. Is it okay now?
Yeah,
But
it's okay
it's
now. Thank you.
zoomed too much, no? Yeah. So point, is it clear? So point class is implementing the runnable interface. So if you implement the runnable interface, you need to define your own run method. So I'm talking about how to create your own thread by using runnable interface. No, here point class is implementing the runnable interface and it is defining its own run method. So now this point class you can run as your own thread, as separate thread. So how to do that? So now you are creating the point object of point. So yeah, you have created the object of this point, and now you have created the thread, that object of thread, and for the thread you are passing the runnable object, that is p1. So you are passing the p1 object which is runnable. By using this process you can create the runnable thing, and you need to start your thread. So t1 dot start, that it will make your you will initiate your thread. That means it will run it will run in parallel to this main thread. Okay, so the thing is like you need to what implement, your class need to implement the runnable interface. You should define your own run method. You need to create the object of that runnable class, and you should pass this object of runnable class to the thread, and you need to start the thread. That is how you can create the thread, or you can create the thread simply by extending the, so you can simply say class point extends thread, and you can define your own run method, and you can what you can create point what your own thread point p1 equal to new point something. That means that is p1 is a thread, no, because it is extending a thread, and you can simply say p1 dot start. So in that way you can create your own threads. Yeah, is it clear right now, or is there any doubt? Okay, I hope no doubt. So I'm stopping here, and yeah. Yeah, I think Anand sir can continue, right?
Yeah, thank you, Nalini.
Mhm.
Arup sir, I'm not able to share my screen. Uh,
I'm checking.
okay, sir. Okay.
So before that is solved, just a general question to all of you: which part? I mean, in these new weeks now, the weeks that we are discussing. So in these weeks, which part you all are facing more difficulty in understanding? Or I mean, you may say it in terms of topics.
So threads.
Sir,
Sorry?
semaphores and generics.
Generics and semaphores. Okay.
Anand sir, can you check? Sorry, Bhaskar.
No, fine. Okay. So
Okay,
generics was discussed. Okay. Fine. Okay, thanks. Yeah, Anand sir, you can continue.
is my screen visible, sir?
Yes, sir, it's visible.
Yeah, okay, thank you. Okay, so good evening, everyone. So now let me discuss about week 12. Okay, so here week 12 totally to develop the GUI, okay, GUI screens using Java. So GUI programming. Okay, so before going to discuss about GUI programming, first we need to know about how to interact with Java program. Okay, so if we want to interact with the Java program, okay, whether here there is a Java program, okay, so whether you are a developer or you are an end user, doesn't matter. But if we want to interact with the Java program, we have two ways. So one is CLI, command line interface. Second one is graphical user interface. For suppose my program is, okay, my program is, I want to perform, okay, arithmetic operations using, okay, so I want to perform arithmetic operations. So I written one Java program. Okay, now I can interact with this program in two ways, by using CLI and GUI. Okay, so now let me show the programs. So see, this is one way. So this is command line interface. Okay, from command prompt. So you see here Java C edition.java, Java edition. Okay, now you are interacting with your program through the command line. Okay, through the command line. So here it is asking for the input. Enter A. Okay, A value 10. Enter B value 20. Okay, now please enter operation. Okay, so here addition, subtraction, multiplication, division. If you want to exit from the program, enter data. Okay, so now see here plus addition is 30. Now again it is going to ask. Okay, so 10, 30. So this time I don't want to continue with the program, just I want to exit from the program. So data. So this is called CLI. Okay, command line interface. So here I am interacting with the Java application using, okay, using command line. Okay, now see. So this is what GUI, graphical user interface. Now same thing. So see here 10, okay, 20. Now I'm going to click on whatever the operation you want to perform. Based on that, you can click particular GUI component. So this is one GUI component. Enter A is there, no? So this is, okay, label. This is text field. This is label and this is text field. So there are two text fields and two labels. So these are called GUI components. Okay, this is graphical user interface. Okay, by using this graphical user interface, end user or developer can easily interact with the application. Okay, now I'm going to click on add. See here, addition is 30. Okay, now I'm going to click on sub. See, subtraction is minus 10. See, multiplication is 200. So this is what graphical user interface. So in this graphical user interface, there are some graphical elements. Okay, GUI components. We can say like a graphical, okay, user interface components. Okay, GUI components. Okay, which are used to create the GUI screen. Okay, So see here, enter A is there, no? So this is called a label. We can also call input, okay, field name. So see here, okay, here text box is there. Okay, here also text box is there, but we don't know what to enter in this text box. Okay, now here I return what? Enter A. Okay, enter B. Okay, so here we have to enter A value. Here we have to enter B value. So that is known by the input field name called label. Okay, so this is the label. Okay, it will tell what to enter in the text field. Okay, so all these are called, okay, all these are called what? Graphic GUI components, simply. Okay, GUI components. Okay, so CLI is there and GUI is there. Okay, so by using GUI we can easily interact with the, okay, application. Okay, so now only one question. So which one is the better, CLI or GUI? Which one is the best way to interact with the Java program?
Sir, GUI.
Okay, GUI. No. So here, how to interact with the Java program is completed. Okay, here we have two ways. First one is CLI, command line interface. Second one is GUI, graphical user interface. Okay, so now GUI is the better. Okay, better one. Okay, in order to, okay, so interact with the Java program. Now, how to create the GUI, graphical user interface in Java? So we have, okay, two ways to create the GUIs. First one is the AWT, abstract window toolkit, and second one is the Swing. Okay, so AWT API is there and Swing API is there. Both are used to create the GUI components. Sorry, GUI screens. Okay, so see here, what is the difference between AWT and Swing? Okay, both are used to create GUI only, but here AWT components are heavyweight. Okay, why we call AWT components as heavyweight? Because AWT components are depend on the operating system. Means if you create any GUI screen by using AWT components, the appearance is differ from OS to OS, because all AWT components are depends on the operating system, but Swing components are not depend on the operating system. So those are, okay, independent of the operating system. Okay, independent of the, means here Swing components are platform independent. AWT components are platform dependent. Okay, so if you execute AWT program in Linux operating system, it will give one type of, the appearance may be different in Linux operating system. The appearance is may be different in, okay, Windows operating system. But if you execute Swing program, okay, so in every operating system it will give same appearance, because Swing components are, okay, Swing components are platform independent. Okay, so that's why we call, so AWT components as heavyweight and Swing components as lightweight. Okay, so Swing components are not depend on the operating system. Okay, AWT components are depend on the operating system. Okay, so AWT components are platform dependent, Swing components are, okay, sorry, AWT components are platform dependent, Swing components are platform independent. Okay, so both are used to create the GUI screens only. Okay, so now how to create, sorry, what are the steps required to create the GUI screens? Okay, so here we have two options to create the GUI screens, AWT and Swing. Okay, so here you should follow the same steps for AWT and Swings. Okay, see here, so these are the steps required to create the GUI screens. See here, first we should create a class by extending JFrame or frame class. Okay, so here JFrame is a, okay, JFrame is a frame class of the Swing API. Frame is the, okay, frame class of the AWT API. Okay, so JFrame is belongs to Swing API. Here frame is belongs to AWT API. Okay, so here first step we should create a class by extending, okay, by extending either JFrame class or frame class. Okay. So here, if you want to create, okay, GUI using, okay, GUI using AWT, then you should extend your class from frame class. So if you want to create GUI screen by using swing, okay, you should extend your class from JFrame class. So whenever you create a class, okay, by extending JFrame or frame class, automatically window or frame will be created. Okay, you no need to create the object for frame or JFrame. Just okay, so extend your class from JFrame or frame, automatically a window will be or a frame will be created. Okay, next, create GUI components. Okay, so based on your GUI screen, okay, so you can create the GUI components. Okay, see here, for suppose, so this is my GUI screen. Okay, so here I required one label. Okay, one label I required and one text field, one button. Okay, so now I need to create these, okay, GUI components. Okay, so for this requirement I need these GUI components. And in previous example, see here, okay, here, okay, according to this requirement I required two labels, two checkbox, two text fields, and four radio buttons. Okay, for radio buttons. So this is my requirement here. Okay, so based on your requirement, create GUI components. Okay, so this is the second step. Next, add GUI components to the panel. Panel is nothing but subpart in a window, simply. Okay, we can say frame is there. Now frame is nothing but your total window. So in that, panel is a subpart in a window. Okay, subpath in a window. For suppose, see here, so not this here. Yeah, so this is your GUI component now. Okay, so here, so paint, so how to create this frame. Okay, so this GUI screen. So first we need to create what, window. So like this. Okay, how to create the window? You no need to create the window, just create a class and extend your class from JFrame. That's it. So window is created. Now create GUI components. So what are the GUI components required here? Label and text field and a button. Okay, so create these three. Okay, and add, so what is the third step here? So add GUI components to the panel. Okay, so now panel is what? Subpart in a window. Okay, so here there is a separate panel. Okay, separate panel is there. 1 second. So this is frame and so panel. So create three GUI components now. Here, what are the three GUI components? First one is label. Okay, so label we have to create like so enter number. Okay, enter number. After that we have to create what, one text field. After that one button. Okay, so button name can be anything. Okay, so factorial, for example. So these are the three things I created, and you should add these three things to the panel. Okay, so panel, so like this. Okay, okay. So assume that this is a panel. So add these. Okay, these. Okay, GUI components. Okay, GUI components to the panel, and add this panel to the frame. That is the fourth point. Now you should add this panel. Add this panel to the frame. Okay. Okay. In which direction you want to okay add? You can add in any direction. Okay. So in this direction I want to add. So I'm adding to this direction. Okay. So this is fourth point. And last point is the call set visible method to visible GUI screen. So by default, set visible method is false. Okay. So by default, so set visible of false means you are not able to view the GUI screen. Okay. So whenever you call set visible of true, then only you are able to view your GUI screen. Okay. So these are the steps we have to follow while creating the GUI screens. Okay. So see here, first we have to create a class. Okay. By extending JFrame or frame class. Okay. Here I want to extend JFrame class. So as a first step, okay, as a first step here, class is created with the name factorial GUI. Okay. And extended it from JFrame class. Okay. So now one frame is created. Okay. This is the first step. Okay. Next, what is the second step here? Create GUI components. Okay. Create GUI components. Okay. So here I required one label, one text field. Okay. One text field, and here one button. So here I entered 5 and I'm going to click on find factorial. So here, see here, factorial is 120. So this is another label. So this label, this label appear dynamically. So whenever we click on find factorial, then only it should be visible. Okay, it should be visible. I'll let you know, how to generate this label dynamically. I'll let you know later. Okay. So see here, or suppose here I given 6 here, and I'm going to click on find factorial. See, factorial is 720. Okay, so this label, generated dynamically. Okay, so see here, this is one label, text field, and button. So these 3 GUI components I'm adding to panel 1. Okay, this is panel 1, and this here, this is the panel 2. This is panel 2. Okay, so say this is as input panel and this is output panel. Okay, so for input panel I'm adding label, this label and text field and a button, and this is output panel. For this output panel I'm adding one label. This label should be appear dynamically whenever we clicked on the find factorial. So this is my agenda. Okay, so now first, so just I'm creating the GUI screen, that's it. Okay, so here, so we should follow these steps in this program. See here, first I created a class by extending JFrame class. Okay, so first step is over. Next, to create GUI components. See here, J label, input label, output label. Okay, input. Yeah.
So why did we implement the action listener interface?
Yeah. I'll let you know later. Okay, that is event driven programming. As of now, I'm discussing only how to create GUI string. Okay.
Okay, sir.
Okay, after that I will discuss. Okay. Yeah. So here input label and output label. Okay. So this is input label. Enter number is there. No, this is input label, and the factorial is 720 or based on the given number. Okay, it will generate it dynamically. Okay, this is output label. Okay. Next to text field, only one text field TF and only one button. Okay. Now this input label, TF and button, all these 3, these 3 should be added to the input panel. So this is what input panel here. Okay, so here See here, input panel, all of you please observe carefully here. So input panel, text field and button, these three should be added to the, okay, added to the input panel. And for output panel, only one GUI component, that is output label, should be added to the output panel. Okay, yeah. Now, so first step is create class by extending JFrame, that is over. Now we should create the GUI components. Yeah, now see here, I'm going to create GUI components. See here, input label, enter a number. Okay, label is created. Next I created one text field. Next I created button. Okay, so these are the required GUI components, okay, for input label. Now I'm going to add, okay, these three to the input panel. See here, I created object for input panel and I'm adding, see here, input label, text field and button, these three I'm adding to the input panel here. Okay, now, okay, now output panel. Okay, for output panel we should add only one label. Okay, that is the output label. So I'm creating output label. So here, so output label is empty. Okay, because we should set the text for this label dynamically whenever we clicked on the button. Okay, so here output label, as of now it is empty. Okay, so now I'm creating object for output label. Now I'm adding this output label to the output panel. Okay, so this is the third step. Okay, third step is over, add GUI components to the panel. So I created GUI components and I added GUI components to the panel. Okay, so here we have two panels. Okay, so for two panels I added components. Now what is the fourth step? Add panel to the frame. So here we have two panels, input panel and output panel. So you should call add method directly here. Okay, so here you are adding panels to the frame, panels to the frame by calling add method directly. Yeah, now here you should, okay, select the direction, in which direction you want to add the panel. So input panel I want to add in north direction. So this is the north direction and this is the south direction and this is the east direction and this is the west direction and here this is the center. So in 5 directions you can add, okay, GUI components to the frame. Okay, so this is north direction and this is south direction. In north direction I want to add the input panel. See here, input panel in north direction I want to add, and I want to add south direction. Okay, for suppose, see here, here I'm changing south north. See, okay, so 5. See, but it is not looking good now. Okay, input should be in top and output should be, okay, bottom. No? So this is not good appearance. Okay, that's why, okay, I want to, okay, I want to set panel 1 position in south direction and the output panel direction in north direction. Okay. So now I'm changing north and then like this. Okay, so this is only, okay, to create the GUI screens. Okay, so GUI screen, so these are the steps we have to follow while creating the GUI screens. Okay, but by using AWT and swing, just we are able to create the GUI screen, but we are not able to perform operations behind the GUI screens. Means whenever we clicked on this button, I want to find factorial of, okay, whatever the number we entered in the text field. Okay, so by using AWT and swing, we are not able to, okay, perform operations behind the GUI screens. Okay, So if you want to perform operations behind the GUI screens, we should use event driven programming. Okay, so AWT and Sphinx just okay create GUI screens. But if you want to perform operations behind the GUI screens, we should use event driven programming. Okay, here, so every GUI component, okay, every GUI, whenever you clicked on, okay, whenever you clicked on particular GUI component, okay, one event is generated. Okay, one event is generated. For suppose, if you clicked on, okay, if you clicked on button, okay, button, action event is generated. Okay, action event is generated. Okay, this action event is listened by the action listener. Okay, action event is listened by the action listener. Okay, so here whenever you clicked on, okay, any GUI component, okay, not only button, okay, so keyboard, okay, so for suppose you have keyboard now, so in keyboard if you press any key, okay, if you press any key, key event is generated. Okay, key event is generated. Okay, so this key event is listened by the key listener. Okay, key listener. Okay, so now every GUI component, okay, every GUI component, okay, has listener interface and event class. Okay, listener interface and event class. Okay, for button, okay, for button, what is the listener? Action listener is the listener interface. And what is the event? Event class? Action event is the class. Okay, action event is the class. Okay, so here action listener method has one abstract method, that is action performed. Okay, so whenever you clicked on, okay, whenever you clicked on button, action event is generated. That action event is listened by the action listener interface. Okay, that's why here, so here I'm implementing my factorial GUI class from, okay, from action listener interface. Okay, in order to handle the button event. Okay, whenever I clicked on the button, so action event is generated. So that event is listened by the action listener interface. That's why I'm implementing my class from the action listener interface. Okay, so now here I'm adding this action listener interface to my button. See here, add button dot add action listener of this. Okay, so now I'm going to click on, see here, this is my screen now. So I entered 5. Now,
So can you explain the last line once again?
which line?
Uh,
This one.
It's the line on 28th.
Yeah. So here I'm adding, okay, action listener, okay, action listener to my button. Okay, to my button, because so here whenever I clicked on the button, okay, whenever I clicked on the button, okay, event is generated, no, action event that should be listened by the action listener interface, no. So that's why I'm adding action listener, okay, action listener to my button. Is it okay?
And so why are we passing this
This means current class object.
current class? Yes.
Yeah. Okay.
Okay.
Okay. So now, whenever I clicked on, okay, so whenever I entered 5 and whenever I clicked on 5, okay, 5, what happened? So whenever I clicked on button, immediately which event is generated? Action event is generated. That is listened by the action listener interface. Now this action listener interface, see here, Java P, Java dot AWT dot event dot, okay, so action listener. See here, this action listener interface has only one abstract method that is action performed. Okay. Now, whenever you clicked on, this button, okay, what is the operation you want to perform? Okay, that operation you should write in the action performed method by overriding it. Okay, you no need to call this action performed method. Okay, so action performed method automatically called by the action listener interface. Okay, so see here, anywhere, see here, just you are calling what? Sorry, just you are creating object like this. Okay, means here only constructor is calling, but in your program anywhere, okay, is there any point? Okay, you call this action performance method anywhere? See the program anywhere. So in this program, okay, there is no point, okay, to call this action performed method. Okay, we no need to call this action performed method. Okay, so this action performed method is automatically called by the, okay, action listener interface. Okay, whenever we clicked on the button. Okay, so here I entered 5 and I'm going to click on find factorial. Okay, for suppose I'm changing the value to 8. See here, see here, 40320 means here you are going to click on button. Now action event is generated. That action event is listened by the action listener and it is going to call, okay, which method? Action performed method. Now, okay, now you should write, okay, required code whenever you clicked on the button. Okay, so here what I want to do, whenever I clicked on find factorial button. Now, whenever, okay, I clicked on find factorial method, so I need to get whatever the text I have entered in the text field. So this is the text field, no? So I want to get whatever the text I have entered in the text field. Okay, so see here, I'm going to get, okay, so tf dot get text. Okay, tf dot get text means here you entered 5, no? So I'm getting that text. Okay, so this text, okay, by default it is in the form of string, but here my input is of type integer. So I'm converting, okay, my text into my required data type integer by using wrapper class. Okay, integer dot parse int of tf dot get text. Okay, tf dot get text. Okay, so here your 5, here you entered 5, no? So here number 5 is in the form of string. Now I'm converting it into my required data type integer. Next, I'm going to find factorial of a given number by using this code. Okay, by using this code. After that, so initially, okay, initially output label is empty, no? So there is no text for output label. Okay, now I'm setting the text for output label now by using set text method. So output label dot set text. Okay, what is the text? Factorial is plus factor. Okay, so whatever the factorial, okay, you find by using this code. Okay, I'm adding to this string. Okay, now so see here I'm changing it to 7. So now I'm going to click on find factorial. So whenever you click on find factorial, what happened? So immediately action event is generated, that is listened by the action listener interface, and it is going to call the action performed method. Now whatever the code you have written in the action performed method, that is going to be executed and result will be displayed like this. See, factorial is 504. So this is event driven programming. Is it clear?
Yes, sir.
Okay. Anybody have doubts? So you can ask. Otherwise, I will hand over to Bhaskar.
So this much is sufficient for EndTerm exam as far as this event-driven programming is concerned.
Yeah, and yeah, it is fine. But we have some extra things like a set action command and get action command. Those are also discussed in the lecture. So if you go through the those slides, you can easily understand. Okay.
Okay, sir.
Excuse me, sir. Sir, I'm having one doubt.
Yeah.
May I?
Yeah.
Sir, set action command that must come with the add action listener. Although without add action listener, I cannot use set action command. Is it correct? I tried that doing, but it was showing error. The line number 28 button dot add action listener in bracket this, and then suppose I want to use set action command, then this line is must. Otherwise, that is not going to detect the event.
Yeah, because we should add this add action listener. No. Okay. So because
Correct.
whenever you clicked on the button, okay, that should be listened by the listener. No.
Okay.
So we should add
Yes,
this action listener. Okay. Yeah, that
Yes,
is
sir.
mandatory. So whether you use yeah, in that way or this way, but this is mandatory.
Yes, sir. Now it's clear. While in lectures, in live session you conducted, na, I thought that was optional.
No.
That's why I
That is
wanted to
mandatory.
clear. Yeah.
Yeah.
Yes. Thank you, sir. Thank you so much.
Okay.
So I didn't get this point. Can you explain this once again? Which
one?
is this the line 28 is mandatory in which case?
Yeah, here you want to handle the events, then this line is mandatory. For suppose you want to add, you want to handle, okay, keyboard events, then you should add like this, add key listener. Okay, so key listener of this, like this, add key listener like this. So if you want to handle button events, then you should add like this. Okay, listener to the button like this. It is mandatory. So if you want to, for suppose, see here. So one second. So this is my GUI screen, no? So already I said what I said. So whenever you clicked on this button, okay, action event is generated, no? So action event is listened by the action listener interface. Okay, so action listener interface. So that's why I implemented, okay, action listener interface to my in my class. Okay, so now what I'm doing is, so in order to listen the event, okay, listen the action event, I'm adding this action listener to my button. Otherwise, my action listener interface won't listen the event, action event, which is generated by the button. Is it clear?
Yes, sir. Yes, sir.
Yeah. Okay. So, Bhaskar, are you there?
Yeah.
Yeah. Okay. Shall I stop?
Yeah. Any more question on this topic?
No, sir.
Bhaskar, you can start.
Okay. Yeah. Then I can start. Okay. Is my screen visible?
It's loading. Yeah, it's visible.
Yeah, it's visible now, sir.
Oh, okay, fine. Okay, so I will continue from where Danya ma'am left. She told you regarding the concept of, this mutual exclusion and synchronization little bit. How do we do that in Java? the coding part that we will discuss now. And then I would discuss a few questions that you had asked on discourse regarding threading and some other things. So let's start it. It would be mainly for your week 11 revision. Week 12 answer has completed and all other weeks are covered. So only the threading part is left, the coding part. Okay. So let's start it. See, threads can be created by extending thread class or implementing runnable interface. You all know that. Not going into detail of that. We have done that multiple times. After that, we know that we define a function run, which is executed by the spawned threads of that class, right? But the difference is we do not call the run method inside the main method. We have to always call the start method, and the start method would in turn call the run method by spawning a separate thread. Okay, if you directly call the run method from your program, then it will not actually create another thread. It would be executed by the same main thread. So we know that. So you always have to write thread, I mean, whatever your thread object name is, that dot start inside the main method, and that method would in turn call the run method using a new thread. Okay, so after that we learned about multiple functions inside threads like sleep and join. So what does sleep do? So one important point is always remember this, that this is thread.sleep. It's not the thread object.sleep. So let's say you have an object called thread T1 equal to new whatever thread, I mean, right? So you will not be able to call something like T1.sleep. Okay, so this is wrong. This is not allowed. Thread.sleep is basically a static method of the thread class. That's why you always have to write thread.sleep. So then how will I ensure that my T1 thread sleeps? The idea is whichever thread will execute the thread.sleep line. So whichever thread will execute this line, that will sleep for the number of milliseconds you have mentioned in the argument. Okay. So if I want my main thread to be asleep, then in the main method, I would write something like thread.sleep. Okay, whatever value. And if I want any particular thread, like let's say T1 thread to be asleep, then assuming that you have a class which is extending the thread class, right? And you are creating T1 by making new that class name, right? I mean, T1 is an object of that class. So you have to go inside the run method of that class, and there you have to place thread.sleep. Fine. You have to place thread.sleep over there. Okay. So then, so basically the idea is thread.sleep. I mean, sleep is a static method of thread class, and whichever thread executes this method, whichever thread executes this statement thread.sleep, that will sleep for the given milliseconds of time given in the argument. Achha, one very important point is that a thread does not release its lock if already gained while in sleep. Okay. And one more important point is, so many students do mistake in this, that see the idea of lock. Okay, I would be jumping a few topics here and there because this is a revision session, so it may not be sequential in that order, because at this point we expect that you all know the basic ideas. This is just a revision. So the idea of lock would only come when you have synchronized block. So unless and until you have synchronized block, there is no lock. There is no concept of lock. Object lock means object lock, right? In Java, whenever lock comes, that means object lock. Because we all know that the abstract idea of monitors is implemented in Java by using locks, right? Is implemented in Java by using synchronized, and synchronized is basically implemented inside by taking these locks, these object locks, right? Every object will have a lock associated with itself, and whenever a thread tries to work on that object, I mean tries to call any method using that object, if that method is synchronized or if that block of code is synchronized, then only we will consider the object lock. Unless and until a method is synchronized or a block of code is synchronized, there is no question of lock, and in that case the context switching can happen in any form possible. Your operation would not be atomic. Fine. So here when I am writing that a thread does not release its lock if already gained while in sleep, that means I'm assuming that this sleep is called inside, is used inside a synchronized method, because unless and until that method is synchronized, you do not have lock. Okay, so you have a synchronized method, inside that you have written thread.sleep. At that time I am saying that since the thread is sleeping, but also is because it is a synchronized method, in the sleep it will not release the lock. So all other threads who want to execute something using the same object would wait and let this thread finish its sleep, let it wake up and let it complete its whole function, and then only it will release the lock, and other threads waiting on the same object would be able to continue their execution. Okay. So next thing is join. Now what is join? Join means suppose some part of the code. So we discussed this. Let's say some part of the code you want to execute in a serialized fashion. So I have let's say what I want to do is I want to have a variable called number. Okay, and inside number I want to do sum of three variables, which is sum, factorial, and let's say another thing, maybe multiplication. Now I have methods for all these three, right? Let's say also I pass arguments inside it. So what I mean is sum equal to sum n, right? This is inside a concurrent part. I mean, this is inside the run method of a class. Fine, run method. And this sum is basically a synchronized method. Likewise, inside maybe in another run method I have factorial, and inside another run method I have multiply. So basically what I want to say is these three are calculated by three different threads. Sum of a number, factorial of that number, and let's say multiply that number by 5. Okay, so this is done by T1, this is done by T2, this is done by T3. Now that's the idea. Now what I want is, see, here I am at first I am calling sum equal to the sum method, sum of n, let's say sum of n. Okay, here I am calling f factorial equal to factorial of n, and again here I am calling multiply equal to okay. So assume all of these three are in run methods, right? And they are executed by separate threads. Now see, sum, factorial and multiply are totally unrelated. I am not calculating the result of one of them as an input to the other one. They are totally independent. They can work on their own. And even if we have context switching between them, I do not have any problem. Only problem is that I want this line to be executed only after these three has completed its execution. So if I have the main thread over here, right, main thread which is going like this, it may happen that before calling the start or before starting the work of all these three methods, my main thread can execute this line. Fine, I mean they have done it. Main method has executed the start of all these three, but let's say it moves forward and before any of these variables could have been assigned, main thread executes this line. So my answer would be 0, number would be 0, right? This is not what I want. I want only this line. You execute all this part parallelly, but I want this line to be executed only after all of them converge, after the threads converge. So in this kind of situation, you would use join. So what I have to do essentially is I have to write a join statement over here. Over here, I have to write the join. So let's say this is executed by T1, T2, and T3. So I would write T1 dot join, right? Accordingly, T2 dot join and T3 dot join. So that ensures that unless and until my T1, T2, and T3 is completing its execution, main thread cannot execute this line, right? So whenever you want something to be executed by threads in parallel, so let's say there are 3 threads, and then at some point I have one operation, this is one instruction which must be executed by as a result of these 3 threads. I mean, these 3 threads result should be input for this instruction, right? So in that kind of situation, you use join over here before executing this line. Fine. You can again have multiple. I mean, after this line, you can again spawn that those threads like this, right? You can do that. You can again respawn them. You can again create another object and start. But this is how it is. That's why this is also called the forking model, no? Fork and join model. We know threads work in a fork and join model. So that's why we call this is called forking. You are forking 3 threads and then you are joining it. Fine. Okay, so join method makes the thread executing this instruction wait for the thread on which join is called to complete its execution. Fine. Achha. Both join and sleep methods can throw interrupted exception. So whenever you actually write join or sleep in your code, either you have to give the throws clause, the throws interrupted exception on top of the method in which you are writing join and sleep, or else you have to handle it in the try catch. Fine. So that's another thing. To check a thread's interrupt state. Achha, so now we are coming to the interrupt. So we learned about this interrupted exception, right? Now when we get this exception actually? What is the reason of, I mean, what is the reason when this interrupted exception is called, right? Sorry, not called, it is thrown. So the idea is if your thread is sleeping, right? Or if your thread is, yeah, so basically when it is sleeping, at that point, if some other thread interrupts your thread, so let's say there is a T1 thread and there is the main thread. Okay. Now your T1 thread is sleeping. Fine. At that point, your main thread interrupts your T1 thread. Okay. So then interrupted exception would be generated. So whenever a thread sleeps, whenever it is in timed waiting state, and there is an interrupt to that thread, which makes it, which wakes it up, in that kind of situation, interrupted exception is generated. Now, what is the practical, I mean, how can you practically do this? How can you interrupt a sleeping thread? So actually, what happens is you may not always need to interrupt a thread. I mean, in most of the normal application, it's not required that much. But when you will design system applications now, then these interruption of threads, interruption between thread is actually used for asynchronous handshake, right? So I'm just giving you the practical idea. It's not required for the course, but asynchronous handshake. So let's say one thread is operating. So let's say it goes to sleep. But again, there is an immediate requirement of something which that thread usually performs. So another thread interrupts that sleeping thread and tells it, okay, so there is an immediate requirement which was unforeseen and you have to wake up and do the work to handle that. So in that kind of situation, what we will do is in the interrupted exceptions catch block, in the catch block, we will write whatever handling it has to do, right? But in general, you should always, I mean, Java will not allow you to write sleep method without interrupted exception. The reason for that is it is a very rare chance that it may occur, but it may occur that you do not interrupt your thread, but due to some system functionality, due to threads are there in your system, right? So due to some system functionality, maybe the thread that you have written in your code, it's sleeping, and at that point some other thread interrupts it due to some system internal thing. Okay, you are not doing that. That's why Java always restricts you to write the sleep or join all these two methods by encapsulating them inside a try catch block or by making the throws interrupted exception clause. Fine. So that is the idea. Achha. To check a thread's interrupt states, now we know that a thread can be interrupted. So to check a thread's interrupt status, one can use the t dot. So t is the thread object, thread reference. T dot is interrupted. Okay, so if you return if you print t dot is interrupted, it would return either true or false depending upon whether the thread is interrupted or it is not interrupted. Right. So let's say no thread is interrupting your thread. So it would return false. But if it is interrupted, then it would return true. One more important point. So let's say your thread is not sleeping. Okay. But your another thread is trying to interrupt your thread. How can I explicitly interrupt one thread? That is done by the interrupt method. So let's say in the main method, let me go over here. What I'm saying is, let's say there is one thread T1, okay, which is executing its run method. Assume that this is the run method which is executed by T1 thread. Okay. In the main method, I have T1 and all those things. I'm not writing that. Assume all those things are here. In the main thread, what I do is I write T1.interrupt. Okay. So this method is used to interrupt a given thread. What will happen is the main thread, it will come, it will execute this line. Okay. It would see that T1.interrupt. That means the programmer wants me, me means the main thread will think that programmer wants me to interrupt the T1 thread. So it would issue an interrupt to the T1 thread. Assume that I have done all the work related to T1 over here, T1.start and all. So T1 is executing over here, and my main thread after that is interrupting T1. But I am telling you that there in this run method there is no sleep. Right? T1 is just going there and executing. So will the interrupt happen? Hello? What do you think? So let's say what I'm saying is in this method now you write this. You are printing T1 dot is interrupted. Fine. And I have given you that in the run method there is no sleep. So what will happen in this case? See, what will happen is, I told you interrupt will only happen. I mean, this exception, interrupted exception will only be generated if your thread is sleeping. Unless and until it is sleeping, there is no meaning of interruption. So let's say if I write over here the try catch block corresponding to interrupted exception inside the run method, I'm writing in shorthand interrupted exception IEE, and then I do whatever, and then I close the run method. Fine, and this is my main method. So in this situation, my interrupted exception, this would never be triggered, because interrupted exception will never be generated because my thread is not sleeping. There is no sleep within this part. That's why although T1 is trying to interrupt, this is not the exception would not be given. Fine. It may be interrupted, but your exception would not be given. it will not raise any exception. So this is also related to a question. I will discuss that a little later on Discourse. I think someone posted about it. So we'll discuss that. It would make more sense after that. So the only thing I'm trying to, only point that you should bear in mind is, unless and until a thread is sleeping, and if another thread tries to interrupt that thread, it would not generate interrupted exception. When you are sleeping, only at that time, if your thread is getting interrupted, then only it will generate interrupted exception. Fine. So you have to sleep first.
Excuse me, sir.
Yeah.
So is that true for join also? Because here it is written as a join and sleep can throw interrupted exception.
See, join will work in a little different manner. So what happens? Sleep means it's timed waiting, right? So there is a time, for that time you are sleeping. Join will wait indefinitely unless and until any other thread has completed the work. So let's say I write t1.join, main thread would not be able to proceed unless and until t1 is joining. So what happens if I write inside the run method of t1, I write an infinite loop. Main method will wait for infinite time, right? So at that time it happens in a different way, right? It's not exactly like this, but you may get interrupted exception. It's not predictable. Okay.
Yes, sir, got it. Yeah. Thank you, sir.
Okay. So this I have told. Acha, one more important point is, see, so to interrupt a thread, you will use the dot interrupt method. Yeah, just give me a minute. Okay, so to interrupt a thread, you will use the dot interrupt method, right? As we discussed in the code. To see the status of interrupt flag, you will use this t.isInterrupted method. But there is another method to check whether your the interrupt flag is set or not. I mean, did you get the interrupt or not? So that method is not is interrupted, rather it's just interrupted. Okay, so what is the use of this? So both your t.interrupted and t.isInterrupted, both of them returns the status of interrupt flag. That is, you are interrupted or not, right? But what is the difference between these two? The difference is interrupted would not modify the value of the flag. It would only return you what what is the current value of the flag. Okay. But interrupted method it would return the value of your flag as well as it will modify the flag. So let's say your flag was true, that is your thread was really interrupted, right? So when you execute this method to check the flag value, it would return the true value, then it would set it to false. Okay, and P dot is interrupted would not do anything like that. It would only return true and it will keep the flag to be true. And P dot interrupt is not for checking the value, rather interrupting your thread. Fine. Now this point is also important, that while writing a multi-threaded program, one can either define multiple classes with their own run method, or inside a single run method you can have the if else case and then you can filter the thread by their name, right, and then work with them. So both approaches we have discussed multiple times in the live session. Acha. So before going to the next slide, any doubt in these topics? Sleep, join, normal threading, interruption. One question regarding interrupt we will discuss at the last.
No doubts.
Okay. So now we are going to synchronization. So this thread synchronization. So now up till now what we have done is normal execution of threads were executing in random order. One thread can race with the other one and execute some line in a haphazard manner. But now we are going to synchronization. So we know the concept of monitors, right? Ma'am also told you, described that. So how to have that feature, how to have monitors so as to enable atomic updates of your shared variable, right? That is what monitor is, that it will only allow atomic updates of any variable that is shared. In other words, it will only allow atomic operation on critical section. Same thing. Critical section is essentially the place where you are updating the shared variable, right? So both ways we can say the same thing, but the idea is it will allow atomic behavior, atomic update of any shared variable. Okay. So that's what it says. Shared variables between threads can show inconsistent values as a result of context switching of threads arbitrarily. So it can context switch in any possible manner, right? So this is what we call race condition. In order to attain atomicity while updating shared variables, the synchronized keyword is used. Now we know that in Java you have synchronized function and you also have synchronized code blocks. So synchronized function is essentially you just write the word synchronized before the return type of the function, right? And in case of synchronized block, you will you will enclose the part of the code you want to be you want atomic inside a synchronized block. So that would look something like this. You write synchronized, then you mention the name of the object on which you want to synchronize, and then it's just a block. So this is the object name, right? Now what do we mean by object name? So when you are calling a synchronized function, so there is no doubt on which object you want to do the synchronization, right? Why? Because a synchronized function would be something like a class would be there. Inside that you have a function. Right. So whenever I will call this fun method, I have to use an object of ABC class. So that means I want to have the synchronization or atomic behavior on that object. That's why I do not have to mention what is the object on which I want the atomic behavior. But when you want to execute a synchronized block, so that may be inside the main method also. Maybe inside the main method you have some lines, and then suddenly you want a part to be executed in a synchronized way. So you write synchronized and then you enclose it within this bracket. But now I don't know on which object you want to do the synchronization. Let's say here we have 3 objects of, let's say, 2 different classes. And both of them are threading. I mean, assume that both these classes are extending thread or implementing runnable interface. Right? So then I don't know on which object you want to call. So that's why here you have to mention that. Whether it is object 1 or object 2. Also, you can mention this. That is also allowed, but in this case, it's not allowed because I'm not. So this is inside one class, right? Because I have not extended the test class with the thread class. Okay, so that's why I cannot write this over here. But if you want to pass any object, so the idea is you can write this or any object name, but that should be a valid multi-threaded class. Right? That is, it should be extending thread class or implement runnable interface. So in synchronized block, you have to mention the object. In normal synchronized method, it's not required because it is already enclosed in a class. So this is done. Next point is Java allows, so that's also done. Programs in which the critical section is synchronized will maintain consistent value of the shared variable irrespective of the degree of concurrency. So it doesn't matter how many threads are executing your method, but once you define your method as synchronized, then in that method you are modifying a shared variable. Then the best way to check is that whether it's a proper synchronization or not, right, is that the output would always make sense. So if you are subtracting 500 or 1000 or whatever from a value, and also on the other hand you are adding, let's say, 200, so the order of subtracting and adding can vary up depending upon the multi-threaded working, right, depending upon the context switching. But what you can always guarantee is if there are 3 subtraction, then the total subtraction would always show, let's say 500 was the subtraction amount for each. So the total subtraction would always be 1500. But if you do not write synchronized, then due to arbitrary context switching, it may happen that before you print the value, right, before you do the subtraction and print the corresponding value, in between that, let's say the context switch happen and another thread prints a different value, right? So it will show a different result. So that's why I want any change on the shared variable and the corresponding printing should be atomic. I will not allow a context switch to happen between the change of that shared variable and printing the value of that shared variable. So that's what synchronized do. Okay, so that was simple thing about synchronization. And then we are coming to intercommunication between threads, right? So synchronization is one level. The next thing that we will discuss in multi-threading is that, okay, one thread is executing, then other thread is executing, but I want this to happen in a not synchronized, but in a mutual understanding kind of way. So let's say that's what producer consumer relation comes in, that a consumer must only consume when producer has produced something, and the producer must again produce when consumer has consumed all the things, something like that, right? So there is a mutual handshake between the 2 threads, or more than 2 threads, whatever. So there is a mutual handshake between threads working in a program. In that kind of situation, I will use wait and notify or notify all to manage the intercommunication between threads. Okay, so whenever I call wait method, what it does is whichever thread executes the wait method, how will we write the wait? It's not any object dot wait, we just write wait, right? So whichever thread will execute the wait method, it would wait, it would go to the blocked state. That's what we have mentioned here. It would go to the blocked state. In case of sleep, it was timed waiting state. Now the thing is, in sleep we know lock is not released, but in blocked state, the thread always loses its lock. That's what that's what my initial idea is, right? Because if my consumer has it has consumed, or let's say the other way, my consumer has consumed all the thing, and producer has not yet started producing. At that time, another consumer thread comes in and starts to eat, but there is no food, right? At that moment, what I want the producer to take control, right? But due to arbitrary context switching, the second consumer has taken control. So I don't want that. I want the producer to take control, and once it produces, then any one of the consumer will start. Correct. So if I want that to happen, if I want the producer to take control, but currently consumer number 2 is in control, so I first have to lose my control. I mean, as the consumer 2, I first have to allow the producer to start working, right? And that's why I call the wait on myself. That is, I wait for some time, right? But it will not work if I do not lose the lock, because it doesn't matter how much time I wait, but if I do not lose the lock, I will not allow the producer to start working. So wait and notify always works by losing the lock. Sleep will not lose the lock. Sleep is just a waiting stage, timed waiting stage, but wait is a blocked state. That's why we call blocked. It's blocked. So unless and until we are notifying again on that thread, it's in the block state. It will not be able to work. So accordingly, notify is the counterpart for wait, that it would signal one arbitrary thread waiting on that object. It's very essential, on that object, not in general, on that object, that the object lock is now free to be gained. I mean, you can now start working by gaining the object lock. And notify always signals all the waiting threads. So let's say you have multiple threads waiting on the same object. Notify will arbitrarily pick only one thread and will, signal that. Notify all will signal all of the threads waiting on the same object. But again, even if they all of them get the signal, but then the scheduler will only pick one of them. So there is not much, what should I say? Not much, viewable difference between both of them. But the thumb rule is, when you are working with multiple threads, then you use notify all. Let's say multiple threads are waiting. So if you have only one producer and only one consumer, then you can use notify. But it's always a good practice, when you have multiple producer and multiple consumer, you use notify all. Okay. Another very important point is wait, notify, notify all. All these methods should always be inside synchronized blocks or methods. So if you try to call wait, notify, notify all on a non-synchronized method, on a normal method, not on, inside a normal method, correct? So it will generate illegal monitor state exception. And this is also quite logical, because what is the idea of wait, notify, notify all? The idea is I would release my lock so as to allow any other thread to start working, to gain the lock and start working. And once that thread finishes work, it will again release the lock and signal me using notify, and then I will again take control by gaining the lock and then do my work. That's the idea. So wait, notify is not like sleep. It releases and gains the lock. So there is an idea of lock inside wait, notify, and notify all. So unless, I mentioned this, unless and until you are inside a synchronized block or synchronized method, the idea of lock is not there at all. Lock will only come into play when you are inside a synchronized block or inside a synchronized method, right? So if there is no idea of lock itself, then what would wait, notify, notify all these things would do? The inherent property of these methods are work with locks, right? And lock will only come into play when you have synchronized. That's why if you write these methods outside a synchronized block or method, right? If you call these wait, notify, notify all, then it would generate an exception. It's illogical, whatever you are doing, right? There is no concept of lock, how you are trying to wait on a lock or notify on a lock. Correct. So you should always have this thing inside the synchronized method. So after I finish all just the theoretical parts, we will just briefly discuss 2-3 programs. Those things were already discussed in the respective live session, but just briefly discuss the program related to all these concepts. So again, before moving to the next part, we are discussing the life cycle of a thread in Java. So these are the various steps of various states of life cycle of a, various states in the life cycle of a thread. Correct. So new is when the thread is created, but is yet not started, right? So let's say I have created thread T1 equal to new, whatever the class name is, right? So at that point, I'm not writing T dot start, right? At that point, it is new before starting, but created. But what is runnable state then? Runnable state means when you have started the thread. Running statement when the thread is actually executing. So if you want to see the running, if you want to see output as running, right? I mean, we can get the state of the thread by using functions. We will discuss that code also. So we can do that by thread dot current thread dot get state. All those things are there. We will discuss that. You also had a programming assignment on that. So not programming assignment, on practice of graded question on that. So that question only we will discuss a little bit again. So running, if you want to see, then only way you can see this is inside the main method. You do it inside the main method, right? And then only, because the main method is printing, then only it will show running. Otherwise, running will not be able. You will not be able to see most of the time. So new is when start is not done. Runnable is when start is done, but it's not executing. Running is when the thread is actually executing. Blocked is when you have called wait, right? You have called wait method, and that's why it's blocked. We saw that a little above. Timed waiting is when you are sleeping but holding the lock. Okay, but holding the lock. See, these ideas are very important when you will have to think what are the possible outputs of a program. Questions like that come now. You have to think, okay, it's sleeping. That means the lock is still held by it. No one can gain that. So that's how we have to think what are the possible outputs. Okay, so that's timed waiting, and then terminated when it has a charge. Terminated has two ways. Either it can be an abnormal termination or it can be a successful termination. So if the thread completes its work and then terminates, that's a normal termination. If some abnormal event occurred, like some system level fault, segmentation fault, or let's say stack overflow, or you have some exception that you have not handled or not defined in the source clause, something like that happens. And at that point, you have written the terminate. I mean, you print the state of the thread, it may be terminated. So there is terminated state can be reached by both successful and unsuccessful way. So we will discuss a short program, but let's finish this and then we will come back. So after that, we see that Java provides semaphore like mechanism. So till now we saw the way to have monitors is, or way to gain synchronization is by using synchronized keyword. But we can also do that by using semaphores, right? But semaphore, as discussed in the lecture, as discussed in our course, is more a theoretical concept. In Java, how we apply semaphores, that is not discussed. So we discussed the pseudocode kind of thing, the pseudocode idea of the semaphores. But Java also have semaphore that we define using the semaphore class. So we write something like semaphore obj, right? So obj is a semaphore, and then you write obj.acquire and obj.release, most probably, yeah, obj.release, I think, right? So this is like p operation of semaphore, p of obj, and this is like p of obj. So this is theoretical, this is practical. So Java also has that, but that's not in our syllabus. So let's not go into that. But somewhat like semaphore, we can get using reentrant locks, or basically locks. Okay. So just keep in mind there is a subtle difference between locks and semaphore, not from your coding idea, but from the way it works, right? So that slight point of difference is semaphore can be executed by different thread. So let's say you write P of S, right, and V of S. Now how locks work is just like synchronized. So in order to do lock, right, semaphores I discussed, acquire and release was the call. In locks, it is lock and unlock. It is lock and unlock. We do not write release or acquire. In semaphore, we write release and acquire. So the difference between lock and unlock and the semaphore's idea of PV, or which we write in Java using acquire or release, The difference in idea is unlock and lock. I mean, a thread can only unlock a lock, right, when it has already gained the lock. Now it seems very trivial. I mean, that's obvious, right? It can only unlock when it has already done the locking. But that's not trivial. The difference is only one thread. So whichever thread has gained the lock, that thread can only unlock that lock. But in semaphore, the difference is if a particular thread has gained this acquire on a semaphore, it may be the case another thread, a different thread, does the release on that semaphore. And depending upon context switching, this will happen. Okay. So just so that you do not run into a wrong conception about it, we are mentioning this, but it's not required directly for your syllabus. Locks are not exactly like semaphore from the system perspective, but from your application perspective, you can assume locks and unlock. I mean, locks are same as semaphore, kind of same as semaphore. So that's why we have written Java provides semaphore-like mechanism. Semaphore-like mechanism. Do not confuse this with exact semaphore. To implement concurrency in program using reentrant locks. The only difference is, again, I am just telling, lock can be only unlock lock can be only done by a single thread, but semaphores acquire and release can be done by different threads. So T1 is acquiring, T2 is releasing, totally possible. Okay, that's the subtle difference. But obviously, using both of them, you can gain the same result. You can gain the same synchronization if you are careful about the logic. So let's come back to reentrant locks. What are reentrant locks? I mean, it's quite simple. So just like synchronized, what you did, a block of code which you want to be synchronized, you kept it inside the synchronized interface. Inside the synchronized block. Here, what you will do is you will just write lock and unlock. R.lock, assume R is the lock name. So you would do R.lock. Inside this, you will write the part of the code which you want to be executed in an atomic way, right? And then you would write R.unlock. That's it. And R is a reentrant lock. You define that just like reentrant lock reentrant lock R equal to new reentrant lock. That's it. Acha, one point, always try to put unlock in a finally block. It's not compulsory, but it's recommended, because if your program runs into some problem, some exception, and somehow this unlock is not executed, then assume that another thread is trying to work on your program now. So that thread would be starving. It would not be ever able to work with, start its own work, because just some totally unrelated thread using the same lock has not done the unlocking. Right, so it's always recommended that put the unlock in a finally block, but it's not a syntax error. It will not generate any compilation error if you don't. Acha. Next thing is why we call it reentrant, right? So the idea is thread already holding lock of an object can reacquire it. So already, let's say I have a lock, I have gained the lock, but again I want to gain lock on the same object. Now this may sound a little trivial, but those of you attended the live session on locks, I think we discussed this. Again, shortly I'm discussing that. So there can be a situation where you want to work with methods which can be called independently and which may be called together also. So I think let's discuss that on this code only. Yeah. So this factorial method now, you have this factorial method. So see, it's a public method which is returning a long value. So there can be a situation where I may need to call this factorial method directly. So I just call whatever an object of math fun dot factorial. Inside that I pass a value. That's what I need. I just want the factorial value of it. And also there can be a situation where I want to call the display factorial method, because I want to print all these parameters. What is the current hold count of the lock and all these things, right? So display factorial is also calling factorial inside it, right? But I may not always want to see the count of the lock and do whatever is defined over here. I may sometime require to just directly call the factorial method. So this method, factorial method, at times can be called independently and at times can also be called as a part of the default factorial method. sorry, display factorial method. But in both situations, I want this factorial method to be executed in a synchronized manner because it's a multi-threaded environment. So in that kind of situation, what I can do? I will run into an issue. That's what your reentrant lock guarantees you, that you don't have to worry about the reacquiring of the lock. Okay, so you make r.lock here, you make r.unlock here. Let's say your factorial is called independently, then it will be just normal locking and unlocking. Let's say your factorial is called inside this display factorial method. I mean, your display factorial is called. In that situation, at first you will do lock. Then again, when you call this factorial method, you will again gain the lock multiple times. So that's not an issue. But then how all this thing work if I'm gaining multiple lock? The only thing is you can gain as many times lock as you want. You can do r.lock 100 times, but I will not allow, the system will not allow you to get out of the method unless and until you do unlock that many times exactly. Right. So let's say one thread T1 has gained the lock, has done r.lock 10 times, and T2 thread is also there, which is again trying to execute the same factorial method. So T2 would not be allowed to execute factorial method unless and until T1 has unlocked 10 times. So number of times you gain the lock, same number of times you must unlock. Unless the lock is not unlocked same number of times, another thread cannot enter. So that's how we gain the atomic property. So just since we have discussed this, just let's see just the output once again. Although this same program we have discussed in reentrant lock. See here I am calculating the factorial of 8, right? And that's why you see this method would be called first, because I'm calling the display factorial. So first time r.lock would be happening, and lock count at this stage at line number 22 would be 1. Then I'm going inside the factorial method over here and again calling r.lock. Since this is a factorial of 8, right, it would be called up to 8 times. Inside this 8 times, and 1 here it was already called 1 time. That's why you see the lock count 2, 3, 4, 5, 6, 7, 8, 9. 8 plus 1, 9. And then when it returns fact result, we have got what is happening. That is, I'm returning from this method, right? Since I'm returning from this method, how many times this method has gained lock, that many times it must also unlock. So this method has gained the lock 8 times because it was factorial, not 9 times. 9 times because of this lock was there. So this has gained only 8 times. So it must do 8 unlocks, right? So that's why after doing 8 unlocks, it would return the result. So at line number 24, your lock count is 9 minus 8 equal to 1. That's why you are seeing lock count equal to 1 over here. And at last r.unlock, when this line is done, it is also lock count is getting to 0. A brief discussion. If you want, you can see that session again. There we have discussed it in detail. Okay, so after that, the next thing is thread safe collections. Fine. Thread safe collections is that, let's say, now we have discussed only normal codes. We have not used any collection in multi-threaded environment. But suppose you are working with multi-threaded and working with collections in a multi-threaded environment. In that situation, you may need that when different threads are working on the same collection, let's say on the same array list or same hash map or whatever, then I want that all the thread, whatever changes they do, that should be reflected in the collection, right? There should not be any clash, right? So in order to provide that feature, Java actually gives you the concurrent hash map, blocking queue, all these kind of thread safe collections. The only thing that you must know about this collection is if you use this map now, so whenever you need a map, you can use this map and then you can never run into concurrent modification exception. What I mean is, in a multi-threaded environment, in a multi-threaded program, if you use a normal hash map, linked hash map or whatever, right? If you use a normal collection and you use 2 threads, one thread is, let's say, making some changes on the thread, making some changes on the collection, it's putting some value, and another thread is printing whatever is there inside that collection. So what can happen is, let's say one thread starts and it goes into the run method and puts some value in the collection. Another threads on the other hand tries to print that same value. So both of them will actually run into an exception because both of them are trying to do that at the same time. So one thread is trying to modify the collection, another thread is trying to iterate through the collection and print something. So that's a concurrent modification, right? So in that kind of situation, whenever you are using a normal collection like a map or normal map or normal any collection, so you can run into concurrent modification exception. And that will only happen when two threads try to modify the collection at the same time, or one thread is modifying, another thread is iterating through the collection. So basically, whenever you have two threads or more than two threads are trying to access the collection concurrently at the same time, you may run into concurrent modification exception, right? But I will not tell you that, it's not the case that every time you will get concurrent modification, because it may happen that one thread completes its work, then another thread prints the value. So that may also happen. I can never say that there will be a context switch, correct? So it's not that you will always get concurrent modification exception if you use normal data, normal collections, but you may get this exception if by chance the modification done by both of these threads happens together, correct? So the better way to avoid this trap is, to avoid this problem is, you use concurrent hash map or blocking queue. We did not discuss a lot about blocking queue. It's a little bit, the code may become a little bit big, but concurrent hash maps, one or two questions we discussed in your practice and graded question, right? So only thing that you have to remember is concurrent hash map will allow the changes on the map corresponding to all the threads to be done in a proper manner, in a consistent manner. But one thing again is, the sequence of updates is still not guaranteed. That is, I cannot guarantee whether the updates done by thread T1 and the updates done by thread T2 would be in sequence. That is not guaranteed. Okay, so let's say T1 adds three values and T2 adds two values. These five values can be in any possible order, correct? So that is not guaranteed, but I can guarantee you the values would be there. I would not throw the collection would not throw concurrent modification exception. So that was it regarding this. Just slightly, I will go to the program and discuss that thread state. So this was actually one of your programming graded assignment, right? So let me actually copy this and oh, yeah, here it would not, it's quite long. Anyway, so I will just discuss over there. And let's do this. My God, what happened? Just a second. Can you all see my screen? Achha, now I think it will work. My system is hanging. Okay, anyways, Okay, now see. So this question was asking you mainly, yeah, this question was mainly asking what are the possible states that you can gain, right, in this question. Okay, so Arup sir discussed it in that session, but I will just briefly show that because we discussed that in this in the slide. Let's see, when I am T1 dot start, T2 dot start is over here. Before that, I'm printing the get state. So if you see the output, that I'm getting the new state, right? New. Both of them have been created but not started. Once I do the start, right, I should get runnable, but it may not be always runnable, right? So I cannot guarantee that it's not actually started executing and went inside this run method and did its work, right? So I cannot guarantee that. So, but see, one thread is actually runnable. So once you do the start, a thread actually goes to the runnable state. And inside the run method, if you go here and see that inside the run method, we have a sleep. So in sleep, we know it's in the time waiting state. So you see here that my thread, extra thread actually went inside the sleep after being runnable, right? And then it went into, it did the sleep, and that's why it's in time waiting state. Whereas my Turing thread could not actually reach the run method, and within that time only I'm printing the state, and that's why it's showing the runnable. So after calling start, it would always be runnable. And if it goes to the run method and executes its work, which is sleep over here, so in that case, since it is sleeping, it would be in time waiting state. Fine. Another point is that this is a synchronized method, correct? So if my method is synchronized, when one thread is gaining the lock, another thread will, cannot gain the lock, correct? So at that time, what will happen is one thread will execute, the other thread would be in the block state, correct? Because we know it would be waiting for the thread to be executed. Waiting for the lock to be left, and it will, for the other thread to complete its work and release the lock, because the method is synchronized. So that's why it is in the block state. And later, when both of them completes their work, they are terminated. Okay? So this is the idea of basic thread states that we discussed. I did not go into the detail. You can see the session where Arup sir has discussed this. Yeah, so that was it. It's quite late, but I saw a few discourse questions. I would just discuss one then regarding this question. Okay, so you asked that I'm not able to understand how this is working. So the thing is, this is the same thing that we discussed. It's using interrupted. So what's happening over here? Let's see. I have created one thread class thread 1 and 5. So we are copying 1 into x and n into 5. Correct. Over here in the run method, what we are doing is, we are doing, if the number is an even, not an even number, then I would print the value. If it is an even number, then the thread will sleep. And after that, we'll print the value n, which is 5. Correct. So what will happen? Let's say the first iteration, thread comes over here. It executes if i% not equal to 0. So obviously 1 is not 0. It starts from x. X was equal to 1 and n is equal to 5 in the parameter over here. So 1 is not equal to 0, so it would print 1. So the result would be at first 1. And one more point. So first of all, it would execute this line. I forgot that. So we know that thread.interrupted, right, would return the interrupt status of the thread. So let's see, in the main method, you are actually calling e.interrupt. And here it is e.start. So there can be two possible things. Either e.start, before start executing this run method, e.interrupt has already occurred. Or another way, e.start has happened, but e.interrupt has yet not happened, and before that only the thread has executed this line. So this line can either fetch you true, or it can also fetch you false. Let's say the first case, when it is fetching true, that is, it has already been interrupted. That means before e.start is done, but before it execute this line, e.interrupt is executed by main thread. In that situation, thread.interrupted would return you true. But since this is interrupted and not is interrupted, that's why it will revert the stage. It will set the interrupt flag to false. Right. So after that, what will happen then? So true is my first line of output, and then 1% to not equal to 0 would be true. So it will print the value of 1. So true followed by 1. Then when the loop iterates for I equal to 2, then thread.sleep will happen. And after that, 1000 milliseconds, after 1000 milliseconds, the 5 value would be printed. So 1, true, 1 and 5 is my current state. After that, 3 would be printed because that's an odd number, right? After that, again, 4, in case of 4, 5 will be printed. And I will only iterate up to 4 because it is less than. So true, 1, 5, 3, 5. That's your output. Now the other way, that let's say that this line has been executed, right? And after that, e.interrupt happens. So let's say what can be the case? Thread.interrupt would return you false in that case. So that's fine. After that, this will start working for I equal to x. So here we will print 1. So what is the current state? False is printed, then 1 is written. Okay, so let's say in the next iteration I equal to 2, this happens. So you print system.out println 2. Sorry, you check this thing, I equal to 2 or not. So it is false. So you will come over here and then you will sleep. Now remember, I told you that in this situation e.interrupt was not called. That's why we got false over here. Then 1 was printed, and then in case of 2, the thread is sleeping. At this moment, e.interrupt is done by main thread. Now remember, I told you that unless and until a thread is sleeping, if you do interrupt, it would not generate the exception. So that's the case. So here, since now it is sleeping and then you are doing e.interrupt, right? So then it will generate exception. So what was my output? This was false because yet interrupt was not done. Then 1, then in case of 2, it was sleeping, and then it got the interrupt. So it would generate interrupted exception. So the exception will only be generated when it is sleeping. That's very important, right? So the output would be false, 1, and then interrupted. So this is the true case output, true 1535, and the false case output would be false 1 interrupted. Okay, so the basic idea is, keep this thing in mind, bottom line, that in order to generate throw the interrupted exception, your thread must be in the sleep state, and then if you do the interrupt, then it would generate this exception. Otherwise it will not generate. Exception will happen, like in the true case you got the exception. Sorry, not exception, interruption will happen because in here you got the true value, but no exception was generated. Exception will only generate when you are sleeping. Fine. So that was it. If you have any doubt, then we will discuss it in the next session on Tuesday. Right? Now this was only the revision, the context part, and in the next session we will discuss all the doubts. You can ask all your doubts that you have regarding questions.
Excuse me, sir.
Yeah.
Sir, how is the weightage this time? Is it equally distributed or the last 4 units are having more weightage?
There would be some more questions from the last 4 weeks, but see, Java, you have to know the previous weeks. Otherwise,
yes, sir,
you will not be able to answer the last weeks as well. So, but mostly it is equal only.
Okay, sir. Thank you, sir.
Yeah.
Thanks, sir.
Sir, will we get a mock test before the finals?
I'm not sure. Yeah, ma'am.
No, Prithudeep, there is no mock. And just like for DBMS, no, I think we feel that you must be quite aware of like how to manage the time and all that. So we don't have a mock.
Okay, okay.
Yeah, if that's it, Bhaskar, we can wind
Yeah,
up.
yeah.
So, or at least people who are here, like please note down all the questions that you have. We will have the Tuesday session and we can clarify all your questions. So, in case you want anything specific to be discussed, for which we may have to put in some homework. I mean, we will have to do some homework. Please post in discourse. Then we will take up those and yeah. Maybe I'll start a thread and discourse asking for any specific questions. That would help, no, Bhaskar? Like then probably we can take that questions from that thread and discuss.
Yeah.
Sure. Okay. Thank you. Thanks, everyone. Okay. Yeah.
Okay.
Thank you, ma'am. Thank you. Good night.
Good night.
Good night.